I love how I'm sitting here with my stream starting thing here while I'm watching vegans. It's the cool new style. What's the cool new style? Oh, we have an echo. All right. So we're going to continue working on this RTMP switcher. Headphones on my head? Do I do dramatic manual readings too? I don't think that I can do as dramatic of a reading as Beacon, but we could try. I used to, until I switched back over to Linux, read Wikipedia pages when people would apply sound effects to my voice. That was pretty funny. Let me get some tunes on here. So I'll quickly, for anybody who wasn't here when we started working on it on Friday, I'll give like a quick overview of what we're building. So if you're familiar with like what a production switcher is that are used, inside conference venues and TV studios and things like that, it's a giant box where you connect SDI and HDMI cables to and stuff like that. You've got a bunch of inputs and then you have some number of outputs, and you want to switch, say like, I want to send camera 1 to, SDI out 2 or something, right? And you can do like picture in picture, and you can layer lower thirds and things like that. So with a lot of conferences and stuff like that going online, there's a lot of services to push to, and pretty much everybody uses RTMP. Twitch, that's what OBS is sending to Twitch right now. YouTube, Facebook Live, all of that stuff, that's all RTMP. And that's great for an individual streamer, but it's not so great for if I want to switch to an MC who's going to introduce our next speaker and things like that, and then switch to the next streamer and have that all be seamless. The best I've seen so far is people like doing Skype and Zoom and things like that. So what we're going to build is an RTMP switcher. So each individual streamer can have their OBS or whatever they decide to use, and they can push to some RTMP endpoint where we can preview it, and then our switcher will go out over RTMP and grab the feed and then send it to one or more outputs. And then we can seamlessly switch to another streamer, or we can do things like, if the bitrate drops for this streamer, we can fall back to a recording of the same talk that they've done. And then in addition to that, if we wanted to create like a linear video television station almost over here, we could have a scheduler where you could schedule certain videos and interlace like live streamers. So this is going to have two kind of use cases. We're going to use it at Microsoft where I work for a project that we have, but it's going to be completely open source. And I'm also going to try and use this for GopherCon, which I'm trying to work on, like how we're going to do this online and have it be a high production value. So that's where we're at. Was anybody here Friday when I was banging my head against the desk for why we couldn't get audio playing here? And if you're new here and you're not familiar with RTMP or video files and how they're multiplexed together and things like that, and codecs and things like that, please raise your hand. And thanks for the follow, Anakim. And we'll stop and we can do a rundown on kind of those things, like what a video container is and how they're multiplexed and things like that. I'm happy to go through that as many times as we need to. So GopherCon is an annual conference for the Go programming language, which I organize with Brian Kettleson. There's a Twitch channel that runs their YouTube backlog. When they aren't streaming, users can submit and vote on the next video. Oh, cool. What, I thought the bot was playing the follower sound now. No, so I have Streamlabs doing that right now. Did that not go through?
Someone finds you interesting, sir. It appears we have a new follower.
I hear it. Thanks for the follow, Arachnoplex. Okay, so raise his hand. Okay, so let's do just a quick overview of how video works. And then we can jump in, and I'll tell you if you were here Friday, I'll tell you what was wrong. You couldn't hear it. It could just be the volume wasn't loud enough. Okay, so when we talk about a video file, we have like the format you're used to, like AVI, MKV, MP4, things like that. That is what is known as the container. And that's just how we package up a video. And inside of that, you have multiple different streams that are multiplexed together. When we talk about streams, we mean video, audio, right? And we could have more than one audio channel if we wanted it in another language. We could have things like closed captioning. Those are all streams that are in there. And different containers will support different codecs. And a codec is how we compress an individual stream so that it doesn't take as much bandwidth or storage space. And there's a bunch of stuff we can get into how all of that stuff works and the different types of frames, iframes, B-frames, P-frames, things like that. But we don't have to think about too much of that about what we're doing right now, at least. So we have all of those things, and the codec would be something like H.264 for video or AAC or MP3 for the audio. So does that kind of, is that tracking with everybody? So now that we sort of mentioned that, we can talk about what we were building on Friday, which is just sort of the beginning parts of trying to use the GStreamer library, which is this library that's written in C for doing pipelining of things. Let's see if we can just look for a GStreamer pipeline example. So this would be like an example pipeline in GStreamer, right? So we have source, then we have a filter. Source only have source pads, and then filters have both source pads and sync pads so that things flow through them, and we can split things up into their own pipelines and merge them back together. And so that is what we are building. It's used for a bunch of stuff, especially inside GNOME. Okay, so we have all of these different things set up where we're decoding a URL, which tries to figure out what type of source it is. And I guess why did we put an audio test source in there? I think this was us just playing around. So anyway, so we had all this working where we had all of it flowing, right? And I'll just do a quick walkthrough. So we have everything as an element, and we basically stitch together these elements by connecting their pads to create a pipeline. So that's what we're doing here. We've got a URI decode bin element, and that's going to take some sort of URL and figure out what it needs to do to fetch it. Is it really RTMP? Is it RTSP? Is it some sort of video file? This is just a test source that just sends a waveform. We were just using this to test stuff. This is converting between different audio data formats. We're resampling it, and we just have like a queue at the source to do some buffering. Here we're converting the video format, encoding it to H.264, and then putting it in an FLV container, which is what is transferred over RTMP. And then a queue on the outside to do some buffering, and then there's our RTMP sync. So a sync is where the data goes, a source is where we fetch the data from. Okay, so we have this issue, and I'll just, are we in the directory? Yeah, so let's just do a cargo run here. And hopefully our builds are much faster this time that my encoding for my stream is offloaded to the the graphics card. On that picture, I only saw arrows out of the switch. What's going in? So this is the switcher fetching from RTMP. And the reason for that is if we had 10 streams going on, we don't want to saturate the switcher, making it do work that it doesn't need to do. So we're going to make the switcher pull from. And in good distributed systems, pull is always better than push. It also allows us to have a declarative state where if the switcher crashed and then needed to be rescheduled on another node, it could pop back up and know what it needs to do, and the streamer doesn't have to find it. Okay, so this is running right now, and if we go out to this weird, why does Google not obey my dark reader? Okay, so this is just a Nginx setup, and it is catching our RTMP and then transcoding it into transport stream segments, which is delivered through HLS. And that's adaptive bitrate. So if you're not familiar with the way all of this stuff works, RTMP is extremely low latency to get it to the server, but it doesn't scale as well for viewers. So what pretty much universally is done is the stream is transcoded into a bunch of different resolutions, as well as split up into, say, 2 to 6 second segments are typical. And then the browser goes out over HTTP, fetches a manifest that tells it where to find all of these segments, and then it'll start fetching them. And if it fails to be able to keep enough video in its buffer, what it'll do is it'll go out to the manifest file and look for a lower resolution and then start pulling segments from that, which is how we do adaptive bitrate. It's also why, like, you may see like Netflix or Hulu or even YouTube or Twitch, the video gets blurry for a second and then fixes itself. That's sort of like a network hiccup where the player wasn't able to get enough data and decided to downgrade. And so that's all this is doing, so that we can get kind of a preview here. Oddly, we can't see the top of that. Okay. So if you notice, oh, we'll have to restream this because the video is over. But if you notice, there was no audio for this video. And we spent a little while I was banging my head against the desk trying to figure out why audio wasn't coming through. And then I realized I'm an idiot. And I just explained to you exactly why it's not. What's wild, Sanus? And so the reason why is if we take this video that we're looking at.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, H09. So here we can do a GST discover. And if we pass it this, we can get some information about this. So the container is a WebM, the audio is Vorbis, and the video is VP8. But if you remember when I described all of this, I said that certain containers only support specific codecs. Well, FLV existed long before Vorbis and VP8 did. So that is not a supported type. Well, they've reused some of the identifiers, but that gets into like some really deep details. But FLV does not support these. Well, we transcoded our video to H.264, which it does support, but we left the audio as Vorbis. So that was our issue if you were here. Yeah, adaptive bitrate really is cool. And the other thing about it that we didn't talk about is all of this is delivered over HTTP, which means that you can CDN it, which is why it scales basically infinitely, as much as your CDN can handle anyway. All right, I couldn't understand how the switch works. Is it, for example, two people connect to the switch, which combines their image side by side and then sends to Twitch? No, so picture this thing that we're streaming to as this right here. So each streamer would have one of these where we could go view a URL and view what's going on in their stream, but it is not connected to the switch. Although it's not like an HTTP request, picture the switcher going out and asking the streamer for its stream and then starting to consume it and then pushing it out to Twitch. So it's switcher's pulling from this direction, pushing this direction. Okay, so let's see if we can get this working now. So do I still have audio in here somewhere? Okay, so let's just change this audio one. What we want here is is it AAC? AAC encode, GST inspect, AAC enc? No. I always forget the name of these. Let's just grep it for AAC. Yeah, maybe the FDK AAC encoder we'll use. Okay, so we want an FDK AAC enc. and we'll just name it the same thing internally. And what this is for is if we want to ask the pipeline specifically for this element. TK, AC, and okay. Let's move. Oh, no, it's right there. Switchers like alt-tabbing between programs. Yeah, that's a good way to look at it. So, Anakim, if you're curious, just look for like production switcher, like a live production switcher and video mixer. And these are used to do like HDMI and SDI and things like that, like physical video connections. But we're essentially creating a virtual one of these to handle RTMP feeds instead of handling hard connections. Okay, so here's our encoder. So what we need to do now is we've already got it added to the pipeline, but we need to link it. So let's see if we can do that. GST element. Can't type, link many, and we need to pass it reference to an array. And then inside of here, what we want to do is we want to link our encoder. Wait, are we already doing that? Oh, we don't even have any of our audio stuff connected. Okay, so here we have convert, resample, and audio. Okay. So what we should be able to do is do a convert, resample, and then we should be able to do our audio encoder, and then we want to connect that hopefully to our FLV mux. Wait. What are you doing, NeoVim? So is audio separated so you can have the audio from streamer 1 and streamer 2, but just the video from streamer 1? Yeah, you could. So you could mix this together however you wanted to. All right, NeoVim, what's your problem? You could do this all you wanted, right? Because
Someone finds you interesting, sir.
thanks for the follow,
Because we
Jengtron.
have a new follower.
So inside of this container that we're getting, right, FLV, we can basically open the container and then we can see the individual streams. And the player's doing the same thing, right? Like when you switch between audio channels, like you want French or Spanish or something like that, right? It's doing the same thing. It's just demultiplexing that stream out. So we could do the same thing. We could repackage it and send video from one with audio from the other. We could layer our own stuff. Like if we want to do lower thirds or something, right? Where it has the person's name, we could do that. We could do transitions. All right, NeoVim just decided to just completely. All right. I think it's my let's just, I'm going to turn this off. I think it's my Rust plugin that's just not, well, we'll give it one more shot and then we'll get rid of it. Source and then source. So lower thirds are if you look at if you ever watch a video and you see like these types of things down in the bottom of, you know, like here you go, that's a lower third because it kind of occurs in the lower third of the stream. So it's just when you embed stuff down there. Okay, so where did we get? Oh, perfect. Okay. Yep, and it's locking up again. Okay. I don't know what's going on with this, but let's just, I'm going to kill that Rust plugin. I think that's what's been the issue. I don't think it's the new LSP stuff. Yep. Okay. So, yeah, it's not the LSP. All right. So we want to do an expect. Oh, wait a second. Maybe it is. I like to play with bleeding edge stuff. So that one seemed to be when I pressed enter. Interesting. Okay. Elements. We'll say audio elements could not be linked. All right. Okay. So the streamer is doing all of the encoding and the switcher's just taking that. Actually, so the streamers require very little CPU because they're just repackaging things. So this component here, which is actually what you're viewing here, it has to do no work because it doesn't have to actually decode the stream. It stays virtually the same because FLV with whatever the encoding type is going to come through here, and then same thing. It's gonna flow this way the same way. And so if we don't have to decode it, even the work that this is doing to build this manifest file is actually very small because the encoding of the audio and video channel are already what they need to be. So the hit is taken on the OBS side. This is just repackaging it, which requires very, very little CPU. Okay, so we've got our convert and our resample, or we're connecting our convert to our resample to our audio encoder, and then connecting that to our FLV multiplexer. So, oh, I forgot I commented this out. Oh, this might not work. Oh no, because we're getting that. Let's see. Elements could not be linked where? $74. Let's see. Oh, wait a second. Oh, we already had this here. That's what we want. What's an example of streamer then? What do you mean? Like, what is streamer 1 and streamer 2? Are we going to play? We have sound. Let's pause the music. We have sound. It lives. Hey, cat peasant, what's going on? All right. So what we have working here basically is this thing that we're seeing here is Nginx running with the RTMP module, and it basically provides an RTMP endpoint for us to push to. And then we have this repackaging it to an HLS file, and we can actually look at what one of those looks like. If you've ever seen these M3U8 files, that's exactly what you are looking at. I guess that would have ended up in my downloads folder. Downloads. Okay, so this is what that looks like, right? So here's our individual segments, and the player is just basically fetching these in order, and we only have one set of them because we have not we're not doing adaptive bitrate. And the reason for that is in this particular one, that's not important. This thing is just meant to be a sink for our streamer so that we don't overload our switcher. What do you mean, Anakim, about the browser connection? So, let's see here. Let's just go to the Excalidraw, and I'll sort of diagram what this is doing here, and maybe that'll make sense. So, can we get a new Excalidraw? Or is it gonna, we can't do more than one? Okay. We'll save this. Well, no, because we shared it. What's another drawing service I could use? Oh, I guess we have a way to load. Didn't we save it here? Where did we save it to? You aren't sharing a live link, I don't think, so don't worry about it. It's actually in the project thing here. I didn't see where it saved it to. Save as. I'm so confused because I don't see it in here. There it is. Okay, so let's see. Yeah, I don't want to mess with that. There's another one I'm thinking of. Oh, here we go. It's Drawy Drawing. That'll work. Oh, and I am terrible at drawing, especially with a mouse. Okay, so we have a video here, right? I really wish I had like a trackpad or something. So we have a video here, right? And we have our switcher. Wow, writing with a mouse is hard. Hey, it kind of looked like I'm writing a script at a doctor's office. All right, so here's our switcher. So our switcher right now is going out over HTTP. And fetching this, right? And then inside of here, this is also, we're going to say this is VP8 plus, it was Vorbis audio, right? Vorbis. Okay. So now what this switcher is doing is it's going out here fetching this, and then it's re-encoding these channels here. We'll just like create like a big bucket here, right? So this is our FLV. FLV. So this is our container, right? And so we're creating two channels inside of that, and we're doing H264 for the video. There should be a period here. So we're sending this, we're transcoding that there, and then we're taking this and we're sticking that in here, but we're re-encoding that to be AAC. AAC. Okay. So now we have our new FLV container. And what we're doing now is we're going to push this over RTMP. RTMP. And that is going over here to Nginx. Nginx. And then Nginx is basically spitting out HLS data. Does that make sense? This is like a terrible drawing, and it will make zero sense unless you watched me draw it, and even then I'm not sure. Okay, so if you weren't here for some of this stuff, there's some interesting things here. So here we've created all the elements. I did walk through what each of those are. The elements can have properties on them that we're setting. So for instance, the URL that the URI decode bin needs, and then the location, which is also a URL for where the RTMP sync needs to. And so here is where we create the pipeline. Then we need to add all of the elements to the pipeline, but they're not yet connected. Back to the drawing for a second. Which one? Which drawing? And then what we do here is we can link them together. So we're linking our incoming queue to our video convert. Then we're linking that to our H.264 encoder, and then to our FLV mux, then to a buffer on the other side, and then finally to our video sync. And then where's our audio? Oh, right here. And this is linking our audio thing. And so the new one. Okay. And then I'll show you all something interesting, because we can actually look at a graphiz drawing of the we can actually look at a graphiz drawing of the pipeline. So this one, what's the question? You good now? Okay. And we can talk about more and more about all of these things, how these things work. It's actually really fascinating how a lot of the video streaming stuff works. Okay, actually, I might already have this enabled. No, I don't. What's the... Did I remove that from here?
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the following, the code guy. I thought we did the dot stuff. We did. Okay, so yeah, so I already set this up. So if we set gst debug dump dot directory equal to here, and then do our cargo run. Now, this will just take a second, but we can kill this off now. And then we can see here, we have our playing.dot file, and I thought I did that. There we go. Dot. That's what I want. And then we can do an XDG open on our playing.svg. Okay. So this actually generates a graphiz document for us. So Nginx is sending the data to the public, right? Nginx is what this URL is. So this, we are hitting the same Nginx on HTTP that our video stream is hitting on RTMP. And do I have an example of how that... I don't think I have the code for that container here, but we could look at Nginx RTMP. There we go. Give me an example. Okay, so here's like looking at our Nginx config, right? So we set up this application, we turn on live streaming, we can configure whether or not it should record what comes in. We can allow and deny who gets to publish on it. And then here we can actually do some FFmpeg if we needed to. We're not currently, but let me give you an example. So here would be if we wanted to push to the my push RTMP endpoint, but then it pushes out to more than one place. So this could be like, say, Twitch and YouTube. Here's if we wanted it to pull. Let's see, do we have an example of... All right, here we go. So here is, we enable HLS for it and where the segment files and manifest files should be stored. And then we have our HTTP server, which listens on a different port. And we have an HLS endpoint that basically just displays those things. How's video sending data to the switch? Who starts the connecting? The switcher connects to the streamer. So the streamer connects to, say, we're going to spin up one of these for each streamer somewhere in the cloud. And then we're going to give each streamer the URL to stream to that. But that effectively goes nowhere. It just sits there by itself, just like this does. So the switcher is then going to, when it's ready, it's going to hit this very same container that's running somewhere and start pulling the stream from it. Okay, so here is our GraphViz drawing of our pipeline, right? So it discovered that we have an HTTP source by decoding that URL. And then this goes into our queue for some buffering. And then we can also see that our video and audio are now separated and basically become like sections of the pipeline. And we can see this go through a resample, the video goes through video convert, then we re-encode the video, we re-encode the audio. They both come together into the FLV mux. And then that is pushed through a queue for some buffering, and then ultimately out to the RTMP sync. Does that make sense? Okay, so now all of that seems to be working. One thing I should probably check is how synced the audio and video is on this, because we might have a timing issue there. Let's just pull that up and watch for a second. Anakin, no worries, no worries. This stuff is confusing. It takes time. I am certainly not an expert at it. You know, I'm familiar enough with it because I spent a few years working for Comcast doing linear video, streaming and multiplexing. All right, let's see. We're just going to watch this for a second and see whether it's timed.
What brings you to the land of the gatekeepers?
I'm searching for someone.
This is going to be hard because it's not like a lot of talking head, I don't think. It seems like it's synced. So we should be good.
Dangerous quest for unknown.
You've not watched Sintel or Big Buck Bunny? You're going to watch a lot of it. So if anybody is unfamiliar with what Sintel is or Big Buck Bunny, we are currently watching Sintel. And then Big Buck Bunny is this other video which we will use. And they are both Creative Commons, so they're allowed to be used. And they're like the only things you can find that way. They're created by Blender. So anything that you do in the video world where people are testing stuff is always with those videos, always. Okay, so now that we have this sort of setup, we can do a couple of things. We can either, one, start trying to refactor this, because this is like just a test pipeline. But ultimately what we need to do is we need to organize these things. Let's just, I don't know. We're going to just create a mixer RS. So, and I am very, very, very new to Rust. So if you see me do dumb things, please correct me. And I'm doing this in Rust because all of the GStreamer and FFmpeg stuff is in C and C++, and I don't want to write that. Are all GST plugins available from Rust? Yeah, the bindings are there. Yeah. And the Rust bindings for GStreamer are actually highly maintained, and they've been rewriting a lot of the GStreamer plugins in Rust, which is one of the reasons why I wanted to do it in Rust. What is this drawing, Xanus? Are you drawing inappropriate things? Oh, that's my drawing. Okay, so we need to create some sort of, and I'm going to draw a blank here how to create structs and types because I'm that new to Rust. But basically we need a mixer type, and a mixer is going to have multiple inputs and multiple outputs. And a mixer is going to represent basically a channel, right? If we think about television terminology. Oh, it's my other mess redone. All right, let's see it. Let's see it. Are you a better drawer than I am? Oh, okay, I got you. So you just sort of, yeah. And so this only works for the very particular thing that we were doing, right? Right now, that video. But sweet. Okay, so we've got a couple of options. So the first thing we can do is this, right? Or the other thing we can do today is we can actually now change this to pull from RTMP. And we could just like stream Big Buck Bunny or something like that to the RTMP endpoint and then make the switcher. We could deploy, I guess, 2 of them and make stream to one Big Buck Bunny, pull from it, and then push to another. Hi, I'm new here. Twitch suggested me this stream. Thought of checking it out. What are we doing today? So we are working on building an RTMP video switcher. We want to build this thing, which is going to go out and fetch RTMP streams and push them out to one or more outputs, and we can transition between them. We could put lower thirds, maybe do some picture-in-picture, and we're also going to do some scheduling of things. Okay, so this one's going to be a little more difficult to test. Maybe we can start organizing the code. So I need to look at the Rust book here because now I am going to completely blank on building types because that's what you do when you're new to things and you sit in front of lots of people and try to build it. It's funny, if I was off stream, I would not have to look this up.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Gavin Gang. There we go. So you're thinking about doing something similar, but using RTSP. Okay, so JT, that's the beauty of what I'm building.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Crateless. So that's the beauty of the thing that I'm building, is it's actually not going to care. It's not going to care. These are just elements, right? So this switcher is going to fetch RTMP, but it's also going to fetch videos because we might want to play stuff here when there's no streamers available, or we might want to fall back to a pre-recorded version of this person's talk when they fall off. So, and this is RTMP out, but you could swap this. So this thing could be replaced by any GStreamer plugin. So you could totally pull from RTSP and push to RTMP, or pull from videos and push to RTSP. Just start throwing spaghetti. We don't mind. Perfect. Yeah. So I'm really new to Rust. I'm trying to get better at it. I always forget how to define methods on structs, because what I want is the new thing. Where is it? Oh, great. Not Go, but Rust. Why Go for Rust? Super stoked looking into Rust as well. So I love Go. I've been in the Go world for quite some time. But all of the video stuff is all written in C and C++, which I don't want to write. But there's really great bindings for Rust. Most people who are doing C++ and moving away from that stuff is doing it in Rust. There's really good interoperability between Rust and C++ with minimal to zero cost for calling out to it. CGO is actually really expensive to call out to Go. So I just don't want to incur those penalties, especially on something like real-time video. All right, so we're going to create our mixer struct, right? And I guess we're going to have
Someone finds you interesting, sir.
inputs.
It appears we have a new follower.
Thanks for the follow, Guardlock. All right, so we're gonna have our inputs, which is gonna be a vec of GST elements, I guess. I think that's what our type was, right? Yeah, GST element. Okay, so that's what we're gonna return. And then we're gonna also have our outputs. And that's also going to be a GST element. Can we hope for a Rust in Action book? There actually is a Rust in Action book, and the writer of it is also a streamer. He is Tim Clicks here on Twitch. Okay, so we've got our inputs, we've got our outputs. This can be the start of it. We might actually have our mixer itself, which would be a GST element, I think. And so the first thing we need to do is our new method, and I always forget what this looks like. It's like impl. Yeah, this whole thing, the build user. But this is just sitting up top. That's not what I want. I want the where it's a static method. I like this Excalidraw site. What's the name of the other one? The other one is drawyDrawing.com. Excalidraw is the one I like the most. Okay. I always forget this, and then I can never find where it's implemented. Oh, right. That's right. So we just put it here, and then it just returns self, right? It's something like, so we want impl mixer, right? And then, yeah. And then I guess we'll just leave this open, and that's going to return back a self, I think is the way this works. And then I guess we can just return back this struct literal. Viga, that's right. Thank you. That's right. Anything that has a receiver, its receiver passed in as its first argument is a method of the type. Anything without is a static method. Perfect. Yeah, it's gonna take me a little bit before these are like so ingrained in my memory that I don't have to look it up. It's kind of funny. I'm super productive in one language, and here I will look like a complete noob. Okay, so this is our mixer. I guess we need to start bringing in some of this code here. I guess we actually need to look up. There are mixer types or elements. We're gonna need to do something like this. Live adder, what is that? All right, let's back up a second and let's see if we can introduce a mixer in here and get that working. Speaking of people who are into Go, I'm probably going to this week do some streaming in the evenings, like at night. And the bot that everybody's using to control the lights and things like that, I'll probably do some work on that in the evenings, and I'll be doing that in Go. So it'll be like Rust during the day and Go at night. Okay, so let's create our mixer. Let's just start with audio, maybe. Okay. Here's our audio mixer. Now what we need to do is we need to add that to our pipeline. Do we need a reference to our pipeline inside of our mixer? We might. So here's our mixer. Proper naming conventions is probably this. We'll fix that when we start refactoring. Okay, so that's added, but we now need to link it. So that's going to go here. Where do we want to put it in our pipeline? So this is, I'm going to rename that. Audio encode, mixer. Okay. So where do we want to put that? Will the mixer handle things in multiple different encodings? Probably not. So let's put it here, and we can experiment with it after. So this is where my knowledge of some of this stuff, like I've never used GStreamer before outside of like command line stuff with it. So this is a learning experience as well. But I love these types of things. I like getting kicked in the deep end and figuring out how to swim because you learn a ton. Okay, so now we have a mixer. Ooh. Oops. I can't type. And audio not found in this scope. Wait, 53. Oh, audio encoder. Okay. Build the link element on line 63. Wait. Audio elements could not be linked. Oh, 76. So maybe we can't use the mixer this way. So the mixer might have dynamic pads, and that's sort of what I'm thinking that we need to do. Let's look at it. So let's do a GST inspect audio mixer. Okay, yep. So we need to request stuff. So these are all like the pad templates. So this is basically saying that we can have more than one sync, and we're going to request it. And the capabilities are the formats that it expects. In order for us to link pads, they need to be able to communicate over a shared format. And that's why earlier our one didn't work when we tried to link it up to the FLV mux. Okay, and so here's our source. So there is a source one that's there always. Can we not? We don't have the option of multiple sources here? Okay. Am I thinking about the wrong element type? Alright, let's see. Yeah, so the borrow checker I've started to, and I really like it. And then there's other times where I was trying to do something with like a shared network connection, and it was ruining my life. Okay, so let's see if we can pull up an example here, even if it's just a command line version of GStreamer. Because I know that you can do this. GStreamer, oh, sorry about your eyes, everybody. GStreamer mixer. Yeah. Audio Mixer allows to mix several streams into one by adding the data. Mixed data is clamped to the min-max values of the data format. Unlike the outer element, Audio Mixer properly synchronizes all input streams and also handles live inputs such as capture sources or RTP properly. Perfect. Can accept any sort of raw audio data. It will be converted to the target format if necessary, with the exception of the sample rate, which has to be identical to either what downstream expects or the sample rate of the first configured pad. Use a caps filter after the audio mixer element if you want to precisely control the format that comes out of the audio mixer. Okay. So that makes sense. The input pads are from GST subclass and have additional properties to mute each pad individually and set the volume. Okay. So this has audio convert coming on the outside. So is that our issue? Do we just need to move our audio mixer? It would appear so. It's because the audio mixer needed to know what format it needed to come out in. So in theory now, we have video playing over here. It's going to take a few seconds for it to catch up and the manifest to be drawn. And we're going through a mixer. Okay. So I think that we are going to want we're going to want the mixer here because we're going to want to be able to ask it for individual inputs and change, like mute them or change their volume potentially. So we'll have to start looking at what the API for that is going to look like. But for now, we'll just assume that we need to do that. So I guess the first thing we should do is, are we going to need the pipeline? Will we need the pipeline? Yeah, let's look at the pipeline, which is interesting because a pipeline itself is also an element. So we might need the pipeline here too. Oh, element. Okay. So we're gonna do this in main because this needs to be done for everything. So all right, let's start thinking about this. Are you going to try and make the switcher interface look familiar for users of the physical version? Yeah, so I started tossing together, let's quickly look at that. So if we just back up here, I started building something in Svelte for this, and it still needs a bunch of work, but we can take a look at kind of where I'm going with it. Okay. So this is on port 5000. Yeah. Oh, so this is going to look really weird because of the dark reader, but this is sort of what it should look like. So this would be like, I threw some examples like Microsoft's Developer Twitch or Learn TV, which is on Docs. So this would be like the scheduler, right? So what videos are playing, or if it's a live broadcast. And obviously I need to clean this up and add some more stuff here. But that's sort of what we're looking at, is like this timeline view of what's going to be on each channel when, and then we can click on one, and then this will slide out. We'll be able to preview what's currently coming in on that channel and decide whether or not, it should be live, and then we can get some information about it. So that's sort of where I'm going with it. Gonna, give some insight into the mixer and what inputs are connected to what outputs. So that'll all be in there, and then we'll like maybe allow the operator to control audio, video, or turning on or off lower thirds, or things like that. So that's where we're at so far. And we'll put all of this online. Like once we get to a certain point, I'll put it all on GitHub. People can submit PRs to it, play with it. That's one of the coolest things is when you get to do stuff like this and just build it completely open source. Okay. I have a habit of convincing Microsoft to let me build stuff that I have for problems I have to solve, letting me build it open source. Okay, so we have our pipeline in here. So the first thing we need to do is we need to create our pipeline, right? I guess we should really... Viga, are you still here? Oh, wait. Impl for struct name. Oh, that was from before. What's the proper approach in a constructor like this for handing back a result? Is that still the right way to do that? Because what we really want to do is something like this, right? Oh, I guess this doesn't fail, right? But we might have something that does fail. We'll leave it for self for now. So I guess we could just do this, right? Pipeline. Oh, and what's the proper naming convention here? Because I'm a Go person. Self is idiomatic. I'm a Go person, so my natural inclination for fields on a struct is to uppercase them. Is it more idiomatic to do it this way? Is that the way you typically see it? Same thing with types. Is this the more idiomatic way to do that? I'm guessing that's the way it should be done. Oh, that's going to be a hard habit to break. All right, and we don't even really need to put that here, right? We can... All right, so there's our mixer. Excuse me. Fields or snake case. What about the name of the type itself? Because I noticed with the GST stuff, right, that the type itself has an uppercase. Types are uppercase. Okay, perfect. I was talking about it on a prior stream. Learning the syntax is actually feels like it's much easier when moving to a new language than learning what all of the proper idioms are for it, familiarizing yourself with the standard library and what's available, what are the common packages that people use for specific tasks. All right, so...
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Zedawap. All right, so we're just going to call this, I don't know, pipeline. Does it need a unique name? I guess we're going to find out. Maybe we should do that. +1 for Clippy. I thought I had Clippy installed, and so that was one of the big things is, I mean, we can do what? Oh, we're in the wrong directory. Cargo Clippy. Okay, so we may need a custom name for this. That may matter when we create more than one. So let's just put a to do here just to think about this. What's wrong with my to do? Does each pipeline need a unique name? What happens if you add a coffee to a milk without adding a coffee to a milk, and a milk without a coffee without a milk or coffee? I'm not sure. If you have cargo watch, you can run cargo watch. Cargo. I guess I don't have cargo watch. Can I just do cargo watch here? No. Is that something I install through my package manager? Alright, let's just do it. Okay. So I'm going to assume we probably need a unique name here, but we'll worry about that when we start dealing with more than one mixer. Okay, so now we in theory have our mixer, but we need to function, we need to add add an input. And I don't know what we're going to take yet, but we're going to return a result. So we just assume a URI. Maybe that's what we should do. I mean, for now we'll do that. We'll say this is a URI and str. We also need an output. But we're also assuming a URI. We could use a file though. Could you like give a layman summary of what an RTMP switcher is? Is it to always have a random source playing on your Twitch channel? Right, so what the RTMP switcher is meant to do is the equivalent of what a video production switcher does that say like exists in a TV station or something like that, where a producer is there and they've got, you know, their let's see, we need one with, so, you know, like you'd have something like this, right? And you've got all the views of the different cameras going on, and you're like, okay, we're going to switch to camera feed number 2. And that's what ends up going out to that output, right? So that's what we're building, except these are all RTMP feeds or videos, and we're going to push them out to RTMP. It could be a video. My particular use case is RTMP out, and it's basically if you say wanted to do a live conference where we can do things like, hey, we're going to quickly switch over to our MC who's going to intro our next speaker, and then we're going to transition to our next speaker, and we can have kind of like this seamless you know, production experience. Is line 13 right? Shouldn't be Peyton. Yes, you're right. Because I was changing my naming around, trying to figure out what the idioms for this are. Okay, so I guess for now we're going to assume both inputs and outputs are going to be URIs, because we can use this same plugin that we have here, or the same element type, to decode it. The fan on my battery backup just kicked on. Okay, so in theory what we're going to do here is we are going to try to do this. Where did that come from? Oh, that's here. Okay, so So this is for two actual needs. So one of them is Microsoft's Learn TV here. There's constantly stuff playing here from like a backlog of schedule. They also have their own Twitch channel, which lots of different people connect to, and scheduling who comes on and like managing stream keys is like really, really gnarly. But also I organize GopherCon with Brian Kettleson, and that's going to be coming up in November. And I would really like a seamless experience that's not like Zoom or Skype or some crap. All right, so yeah, deadline, exactly. I mean, that's the only way things get done, right? Okay, so here's our source. I guess this is a result, so we could just return this back, right? For now, anyway. More honest words of no. And yeah, I fully admit that if you give me unlimited time to build something, I will wait until like a week before the deadline. There's a Discord for Rust streamers. Yeah. So I'm on there. I actually just recently got added to the Rust Stations stream team too, and I'm in there too. So yeah, I want to do some collaboration. One of my coworkers streams a lot on Rust, Ryan Levick, and we've talked about potentially after I get a little bit of code in here, he either on his stream or mine doing some pairing where he code reviews it and you know helps me with all my Rustisms. Yeah, so there's a really awesome TED Talk on procrastination. If you haven't seen it, you have to watch this. TEDx procrastination. Yes. If you have not seen this video, you have to watch this. It's hilarious. Yeah, he basically talks about how, you know, everybody waiting to the last minute and you have like this procrastination monkey in your brain that's just like, let's go watch YouTube. Okay, so I guess we would do a inputs.push our source onto there. We might need to do some other type to match the inputs to the thing in the mixer too.
I can't be stopped.
Okay, so that's gonna go back. If not, so then we also need to do. Ooh. So we're also gonna need a method to play, right? Okay. This is a start. Oh, wait. Each of these are methods, so we need to pass in and self. And self. Okay. And same thing. You need self as well. Okay. So thinking here. So I think we need to also where's the best place to do this? I think for this mixer, we're gonna need. Oh, wait. We need two, right? We need an audio mixer. And we need a video mixer, right? And so I guess when we do this, we need to do the same thing, right? Oh, wait, no, those can return back. All right. I don't know whether I want this to crash or not. I'm just gonna pass it back now. Okay. Oh, we can't do that here. Okay. So I think we need a result here, right? Right? And then we'd have our audio mixer. Does Rust have like auto-generated docs the way that Go does, where we put comments here and it's just bundled with automatically for the documentation? So the other thing we can do here is a video mixer. All right. Okay. So now we have this. And I mean, I may rename this too. Maybe we call it a channel. I don't really know. Okay, so this is where things are going to get tricky. It has ///. Is that where, like, if I do a ///, this becomes docs? That's kind of creative. Okay, so this is where things are going to get a little confusing.
It's super creative.
It is super creative, Zanus. For anybody who's new to the channel, that super creative thing is actually my voice. And it's now on multiple people's channels. That came from when I was doing some of the streaming in Windows. I had VST plugins where people could use the bot to apply them to my voice. And somebody clipped me while saying super creative with a high-pitched filter on my voice. Okay, so let's see. What you got, Viga? Oh, we're going to leave the Rust book open. Never close tabs. That's the rule. Okay, so accurately documenting your packages will help others users know how and when to use them, so it's worth investing the time to write documentation. In Chapter 3, we'll discuss blah, blah, blah. Okay. Known conveniently as documentation comment that will generate HTML documentation. Starts with 3 slashes. Okay. Nice. And it looks like if we use Markdown here, that works as well. Oh, that gets documented as... Oh, no, okay, because it's the whole thing is Markdown. Okay. So we'll have to remember to do that. Okay, so this is going to get slightly more confusing than our sample here, because at this point we sort of know what everything is, but we're not going to later. So, because we don't know what all of the format and everything is going to be. So we might have to just assume for now the output, and we'll refactor later. I think that's... I think we're just going to assume that this is always RTMP for now. I think that's going to be the easiest thing to do for now. And so play is pretty easy here, right? Because play, we just need to come down here and set our pipeline state, self.pipeline, and then I might want to create our own errors here. So this is going to be a result. Can I just return nothing? Because in this particular case, it doesn't really, it just needs an optional value here. Or would this be better? I mean, I could return self, maybe? I don't know. What's a rustism? When you don't actually have a return value here? Okay, so the other thing we need to do is I'm going to copy this all over into the play. Oh, wait a second. When does this get called? Because all of this... Oh, it's iterating for messages on the bus. Okay, right. And then we're breaking when we get that. Okay, so... I guess for now what we can do for play is we will make play synchronous. We may change this. I really want the Rust format stuff to be in here, but that Rust plugin was not playing nice. We'll deal with that later. Okay, so this is sort of our play. We're just going to execute that synchronously for now. So that should all be fine. I mean, I guess we can... And then the other thing we want to do when we create our pipeline is we want this too. All right, let's move this up. Oh, what did I just do? All right, so let pipeline. Okay, and then this debug stuff is ridiculously helpful. Okay. Okay, we're just gonna give it a name. And this is where I'm going to mess up all of this, the differences between types of strings. That can't be right. Did I get that right the first time? I don't think the cargo check is running in the correct folder. You're missing in the play method declaration. Or you haven't saved. I have saved. Alright, I'm in switcher. I'm in here. Do I need to do anything special to get the other... Is it something to do with why, like, Mixer RS isn't being included in the build, maybe? Do I need to do anything special to tell it that this file also needs to be built? Ever done functional programming? I tried learning a bit of Haskell a while ago and found it quite interesting. I haven't done a ton of functional programming. I'm trying to learn that along with Rust. Where is Mixer RS? Oh. Oops. There we go. That's our issue. Is yeah, there's all our errors. There they are. That's still not showing me any errors. Okay, so this is all yelling at me because of this. Alright, why are you yelling at me? Add mod mixer and main RS. Oh, so is each file its own module? Oh, there we go. That's why this wasn't, because it wasn't being included in the build. Help add here. I thought those had specs on them. Let's see. Why does that keep jumping all the way down there? That's weird. Does that have anything to do with this? Try cargo watch -X minus. You're watching the procrastination video, Dr. Doomenberg. STR not a. Oh, I'm dumb. This is name. Name. I want to know why that keeps jumping down here. I've got something going on with my plugins. All right. Expected one of on line 30. Oh, and that's where I'm missing the arrows as well. Okay, so line 30. This is where I'm like mixing up languages. Why are you jumping every time I save? That's really annoying. Go, you don't need this like colon thing. Why are you? Alright, hold on, let's... Now I'm curious if I re-enable. I don't ever remember this sort of jumping issue on save. Alright. What is... Can I not do that? Rockaboo, should I change the aux picture to be... Yeah, so I thought I removed all of that, but... buff, right, pre... Yeah, I mean, I've got the Rust Fump there. What's in post? Yeah, nothing for there. Okay. line 31. I thought these returned back results. 31. It does return back a result. So why does this question mark thing not work? Oh, because I haven't supplied. And what is that error? Not a type. What's the error type? I thought it was just error. Is that right? No. Alright. I'm losing my mind here. There's a standard error type there, isn't there? Is it standard error or something? IO error. Thought there was a generic interface for that. Let's see. What does make return? We'll just return that. That returns back a glib bool error. Standard error. Standard error. Then we should be able to do this. Right? Why not? So, Mr. Halsey, the right person for that question is in the chat. Teach here works on all the LSP stuff. Oh, that's right, the box thing. So, box, dyn, standard, error. Still no dice. What are you yelling at me for now? Here's where I struggle with the language instead of... Oh, wait a second. So, right? Yeah. You should be able to install LSP extensions and get it to work, by the way. And get what to work, Teach? I thought I have LSP extensions installed. I have LSP extensions installed. All right, let's fix some of the other errors. You might have meant to use the available field self.inputs. Yes. Wow, I flew through all of this and self.inputs. This should be the same thing.
Interesting, sir. It appears we have a new follower.
Thanks for the follow, Corpu. So this is going to be the same thing. We don't really need to return back anything, but we do need our error. I'm going to try the stand error thing and see if we can get that to work. Oh, wait. We are missing... Right? Yeah, I'm just going to copy this. Oops. Okay, so I might need to change these because the error type just doesn't align here. So, oops. I just changed to buff right post, for example. That's often enough for me. I'm not sure what you mean. Oh, you're talking to Mr. Halsey? Or are you talking to me? Alright, found keyword let. Oh, okay, so this is just yelling at us for this. And missing lifetime specifier. Yay, my favorite thing ever, lifetimes. Me. You can use the auto command I pasted to get the inlay hints to work. Okay, let's do that. I have a .config nvim plugin. It's under settings completion. Yeah. Okay. So where's your auto command? Auto command. If Vim blows up, it's Tej's fault. We're blaming it on Tej. All right, let's try it. Have you perhaps listened to the Happiness Hypothesis by Jonathan Haidt? The instant gratification monkey kind of sounds like. No, I don't think I have. Oh, did you update more stuff? No, it's all up to date. I just copied whatever you gave me. What was that one? Insert leave, buff enter, buff when enter, tab enter. Yeah. Yeah, I still don't see him. I mean, I see him down in my airline, but... other config I have for what? The LSP extensions? So this is all my LSPs. I have the buff enter one for Lua here. This is just my OmniFunk. And this is all for like Altisnip stuff. Oh, here's the inlay hint stuff for... Did I just override it? Is that what I did? Yeah, so I think I need to comment all of this out, right? I'm just going to remove them all for now. All right. Now let's try it. Oh, I opened the same file. All right, tab, new source, mixer. There we go. There we go. Yeah, so that returns exactly what we think it does. So our issue is that we're not... Oh, there's the semicolon after that. I always forget that. Okay. So... Alright, what are you complaining about? Let's see. Expected semicolon on line 39. What's going on line 39? Oh, because we're missing our arrow here. Okay. Missing our semicolon there. And this is self.pipeline. Self.pipeline. And same thing. Self.pipeline. And then same thing. Self.pipeline. Okay. And lifetime. Is that the best way to do that? Put a lifetime specifier on there? Or do most people use like a, use an actual string class? Undeclared lifetime. Ah, man, I always hate this. And now I know there's something I need to do the struct for this. What is this? Oh, for rocker. Okay. Now, I always mess up the lifetime specifiers. That's the one thing, even back when I was doing a little more Rust than now, that I always messed up. Do I just supply that on my type? Is that how that works? And I think I have to do the same thing on here, don't I? No. It's the other way around? It goes on the function? I feel like this is the wrong way to do this. If you don't care about allocations, you can use string and allocate in the heap rather than str. Okay, let's go that route. Because the lifetimes thing is still the thing that confuses me the most about Rust. Alright, let's just do that. Alright, and so... no method name, debug. Oh, because there's this. Oh no, that returns back. Okay. That's not going to return back a result. So we need a match. On pipeline. Right. No, that says it returns back a pipeline. I can see it in the LSP hint. So why are you saying that doesn't exist? Let's go take a look. Oh, that works. Here's our pipeline. We don't do anything to it. It's just a normal pipeline. So why do you say weird? Yeah, Rocker, I think that's the way it works. I think it has to be on the impl and on the type. And it might need to be on the function too, if I recall. This is really weird. Okay, what am I missing? Okay, here we do the same thing. We call pipeline new. Here, we call pipeline new, right? And then here we do all the add many stuff, which is fine. Wait. Where's our debug? So it's the same thing though, right? Oops, so here we actually need to give that pipeline. H, what does H mean? Oh, am I missing the GST import? I think you are correct. You are correct. There we go. Okay. Expected enum standard result found. Oh, right, because we need online. Okay, so we kind of have the same issue with all of these. So all of our functions that we declared. So for this one, I guess, you know, we would need to return back okay, right? And then same thing for this one. We're going to return back okay. And then oops, that's not what I wanted. What else we have? Expected center result found struct mixer line 29. And missing inputs name outputs. Okay, so I guess we need to supply empty ones. Oh, pipeline is a pipeline. Okay, so first thing, let's fix that. This is a GST pipeline. Okay. And then here it's yelling at us about inputs, and we can just do the vec macro, and hopefully the compiler will figure that out. Outputs. Okay. I don't know yet what that's complaining about. We need to wrap this in an okay, I guess. Missing name. Oh. And then name equals name. Oh, and we need a to string because that something. Hey Tej, are you still here? So this is the one thing I do get randomly, where this will just pop up and it'll just be there forever. There's a set state called that calls the expect set state. Yeah, that's right here. Does that go away if I change? So it's just unique to that buffer. If I close... yeah, so that's the weird thing. Began was talking about this too. You see how you get in like this weird state here? Where now you can't close the buffer while turning it off. And so that's the problem, Dr. Dimmenberg. You can't just turn it off, you gotta crash it. And I think that's the only way I get that floating window to go away, is typically by killing. Yeah, see? And now it'll do it here, and now I'm sort of like trapped in here. We're gonna have to kill it. That's my fault for playing with like super beta stuff. I watched TJ's stream and I'm like, I gotta have it now. Okay, so what is our error here? Help if this is intentional, prefix it with the underscore URI. Oh, unused. Okay, yeah, we're gonna use it. Self is a and reference to the data it refers to cannot be borrowed as mutable. Okay. So super beta stuff is great. Why would I want to wait until it's stable? Then it's not new anymore. So it's actually all of a scheme. So I really want Tej to watch my stream. So I use this stuff so he'll watch it to see how it breaks. It's just, and I intentionally make it break so that he'll do more work on it. Okay, so in this case, we're getting an error because we can't do a mutable. I think this is how we do it, right? And mute self. Look at that. Okay. So now we sort of have this working, right? So we can do the same thing here, mute self, and we're just going to but URID code bin, I don't think, let's check it out. Because I don't think we can use that either. GST inspect, RTM or URID code bin. I think this is only for sources. Yeah. Yeah. Okay. Oh, yeah, so we got stuck in, oh, okay, Dr. Dumenberg clipped it. I got in that weird state that both Began and I have talked about where you get like the one floating window and you can't close it and you have to crash our NVIM to get out of it. Okay, let's see. And then I also said I intentionally use bleeding edge stuff so that you'll watch my stream. Control W will get you to the window. Okay, I'll have to try that next time. I didn't think about that, right? Because I have keys to move around windows. I didn't think about using that. Yeah. Yeah, restarting is kind of the bigger pain. All right, I'm going to just take a quick restroom break, and then we'll continue on this. And I'm just going to leave this scene because I know the second I walk out, you all are going to change it back to this scene anyway, so...
Yeah, it's super creative.
Is it just me, or does Began only host Eric these days? I think he's been raiding some other people too. Beacon needs to start hosting cool people. I totally agree. I totally agree. Okay. Imagine hosting Eric. You can't grow if you host the same person every day. Yeah, I mean, I think it's also convenience too. There's actually not a lot of people on Twitch coding too. I've certainly found. So finding people who like align with you, I think you always end up rating the same group of people, just because that's where they happen to be. Stuck on slice type conversion. You're stuck on it. What do you mean? Okay, so this is... Where did we leave off? Oh, just thinking about how we need to do the outputs. So here, I guess... let's open up the source main. Okay, so let's just assemble these, right? So we need basically all of this, right? And so this would be our output. And I'm just gonna What's the my OPSEC? You don't like hanging out in the channel? Okay. So this is just all warnings because I'm not using these. So now we've got our video convert and all of this going to our FLV mux. Just thinking. Oh, your people are interested in the thing I'm building? Yeah, I think it's going to be really, really cool once it gets a little further along. Okay, so I'm just trying to wrap my head around some of this. So this is the video portion of things. So we already created a video mixer, right? Yeah, okay. So now we need to, we're going to borrow this code here. We need to add all of this to the pipeline, right? I think this also throws an error, right? Right, because it's being unwrapped. $500 a month on Restream? Are you serious? That's insane. All right. I'm going to save you $500 a month. Okay? Do I have the example code on this computer? Yeah, $500 a month is insane. All right, here's what I want you to do. I want you to go and search for Nginx RTMP. Here, I'll link you to it. You're going to set this up. Okay? And down here in this example, we have this RTMP stanza and the server and the port and all of that. And now if you look, these are rules for who can publish. But come down here and see this my push example. This is what you want. This means if somebody pushes to where, what was our application called? Server, my My TV? No, it's its own thing. So now if you push to slash my push, now it's going to push to both of these RTMP endpoints. That's it. That's all you need. And the amount of data that's needed, because this doesn't do the encoding, that's done on your end. I have this running in like a very, very, very tiny Azure container instance. And I don't even know, it'd probably be less than $30 a month. So yeah, go set that up and save yourself $500 a month. And ping me offline, and I will help you, because that's just ridiculous, and that's part of the whole reason why I'm creating this. Is this whole space is just completely overcharged. It's insane. Okay, so we're not using that. So we need to link our video convert. Well, I mean, let's just reuse all of this. Charge $450. We're looking at the next billionaire. Yeah, some of these streaming services want like 20 grand, and it's like, are you kidding me? You are all using Nginx with RTMP and then putting like an interface around it. Okay, so let's get rid of all of this. Well, no, because I guess we still need this for our audio stuff, right? So let's go find our, let's rename this video convert. Okay, so let's, what was source? Let's come up here and get all this stuff. Because we also want our audio encoder, mixer, convert, resample. We're not going to do that. Yeah, okay. So this is our video stream. And this is our audio stream. And let's get rid of all this too. Okay. We don't have source. Get rid of audio mixer. Audio encoder. We're not going to put the mixer in right now. Resample. Get rid of that. Let's move these. Video convert x264 FLV mux. Q before the video sync. Okay. What are you complaining about? I wonder if someone might PR hack chat to be easy to use. Sounds like every firewall, every open source tools, and custom built UI. Yeah. Yeah, the custom hardware stuff can be really expensive. Yeah. Our host uses a Mac. OBS on Mac is trash. Yeah, we're using some like OBS WebSocket control stuff for the Learn TV stuff now. And it works really, really well. It was built by Seth. But, you know, you look at things and we can really kind of start customizing stuff this direction. Oh, because we renamed this to Video Convert. Can I find... Oh, because it's self.pipeline. Self.pipeline, okay. And we renamed that to QSync. Okay. So we've added all of these to our pipeline. And I almost feel like we should assemble these into their own pipelines, because we can add pipelines. We can sort of like nest them. So we might look at that here in the future, but for now, let's do this. So the next thing we need to do is we need to link them together. down here, we can see ourselves doing that. So here, copy this. Oh no, let's comment. Add elements to pipeline, even though it's really obvious, but all right, and now we need link video elements, and that's what this is. And then that can return back an error. Okay. And now we need to link our audio elements. Did that get renamed? Oh no, because we don't have the queue. Okay. Eric.dev, the problem with some of these later rustlings is I can't cheat since the solutions don't exist or aren't easily found. Yeah, that's true. What is your error here? Oh, because qsync, oops. qsync we renamed. Okay. So now we have our video elements. So now we need to link our audio elements. Well, the ones that we can anyway, right? Link many. And so in this case, oh, we need to put our mixer in here yet too. So this would be self.audio mixer. If the borrow checker doesn't yell at me for this, which I have the feeling it is going to. All right, and then this needs to be before all of the conversions, I think. So I think we would have our mixer here, self.video mixer. Help field similar name exists. Oh, did I type that wrong? Yep, okay. Look at this, we're making progress. What is the min upload speed to get a stream going on Twitch? If you want a decent quality, probably 15 megs. 30 if you wanted to do like all out HD. But I mean, you could, right? So like you can do the math on it too, right? So like, what's my resolution? So we have 1920 by 1080, right? Right, times frames per second, right? Well, this is before compression, but so times frames per second times your bit rate, right? Would get you there. But if you've got a constant bit rate, right? Like right now I'm doing 1080 at 4,500 kilobits per second. I think everything's good. So that's what you would need. With some headroom, obviously. But it's surprisingly less than you think you need. I've got 1 gig symmetrical here, but that's just because I'm crazy and I like fast internet. Okay, so now we have, in theory, all of this stuff working. Oh, do I want all this here though? I feel like the output, I feel like these convert and resample should not exist here. Because I don't think we can connect multiple inputs to that convert. Let's just do a GST inspect audio convert. Yeah, it just has 1. So let's not put that there. This needs to come out of here. We're going to change the resampling, and we're going to leave the mixer first. And same thing here. But yeah, you can get away with, yeah, Mr. Halsey streams like really low. I'm really curious to see his configs because I know that he's like dropped down to like 10 frames per second and all of these things to reduce bandwidth needed. It wasn't related to type changing at all? Huh. Okay, so now we have our audio mixer is the last element in our output. I like that. And same thing with our video mixer. They are both connected to the FLV mux. And I guess we have these things here. So, okay. So now in theory, our output is set up. We don't have anything for the URI, so we do need to go set where we're setting our properties here. Okay, so the location, and okay. So we've set the URI there. All right. So now we just need to do the same thing for the input. And then we may be getting somewhere.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, fellow worker John. Oh, so that's the other thing we need to do here. I wasn't thinking about it. So let's assemble like a to-do list up here. So the other thing we need to do is we need to set up a T element so that we can push to multiple outputs. Because remember, we have oh, and what is the output here? I guess it would be the video sync. So we would need to do self.outputs.push. This may not be what we want to push. All right, we're gonna push that for now. The video sync. There we go. Good stream. We need more Rust tutorials out there in the world. So I'm actually very, very new to Rust. I'm a baby Rust programmer. Most of my experiences well, for the last 10 years has been in Go. So I'm still trying to learn Rust, but I'm doing it through creating some crazy project. I feel like I learned better that way.
Someone finds you interesting, sir.
Thanks for the follow, M. Jewel.
Follower.
Okay, so I really think that we probably don't want this here, so let's just add a quick to-do here as well. Agree, Rust tutorials are difficult to find or are already too hard, yeah. Thanks for the follow, Shoe83. Thanks. I appreciate that, Camille. Okay, so where was I my line of thinking here? Oh, okay, so we may not want the sync to be stored here. We may want the encoder or whatever the first thing or whatever the element connected to the mixer is. This is sort of what I'm thinking at the moment. But for now we'll store the final sync. You know what? I mean, I guess it could be the mux. No, I don't know whether I like that. So we'll try and get it working, and then we'll do a little refactoring to figure out whether maybe we can think of a cleaner way of doing this. Because I think that what we really want is... where is our... Oh, we don't even have the video mixer in here. Because we didn't set up a video mixer on this end. So... did we add the video mixer? I think we're missing some stuff here. We are. Oh, this is on main. Audio mixer. Okay, so we are creating both of them. They are being set there. We didn't add them to our pipeline though. We should be going pipeline add many, and we need to add our audio mixer. Oops. Need to borrow that. Ah! I'm bouncing all over. And video mixer to our pipeline. I think... okay. So those are added there. Oh, I guess we already did that, so we can remove that. What is H? I don't even know what that means in my gutter. Okay, so we've created our pipeline. In the pipeline, we've added our mixers. We have a way to reference them. Then we have our inputs and outputs, which currently are probably not important, but we may be able to name our inputs or something too and not necessarily even need these, because the API for GStreamer does allow us to ask for elements based on their name. I don't know whether we can like remove them that way. We'll have to dig a little further into the GStreamer API than I've messed with in the past. Okay, so we're assuming this is RTMP. Video convert. Yeah, I feel like... let's see. We need to link this to our mixer. Self.video mixer. Video mixer. Okay. And then... wait a second. Oops, that's our ad. Oh, we were already doing it. All right, that's linked to our video mixer. That's linked to our audio mixer. Okay, so now we just need to handle the input side and then do cleanup. All right, so currently we're just pushing that on there. We are going to have to do this check. And if you weren't here for the last stream, I'm going to walk through this pretty quickly because it is interesting. So let's just copy this over and then we'll kind of explain what's going on. Okay. I really wish that Rust plugin wasn't like locking up my editor. Okay, so what this is because the URI code bin, we talked about each of these elements having paths on them and you're connecting sources to syncs and, you know, trying to find a data format that is uniform between the two of them, and they'll try to negotiate. So now we have this issue where we have this URI decode bin, but we don't even know what that could be, right? It could be a file, it could be an RTSP stream, it could be an RTMP feed. We don't really know, so we can't know what paths that it's going to have. Well, right? So in this example, what happens is now we can set this callback so that once the URI decode bin element decodes the URL and determines what type of element we need, then it's going to call this callback with each pad that it finds on that, right? So if the URI is an RTMP URI, then it's going to have one particular set of pads. So what happens here is now we're just echoing out that, you know, we've seen a new pad. We're looking at its caps, and we're only doing this so that we can get the structure that's contained within, so that we can ask it what the pad name is. And when we did the GST inspect, we were looking at some of those. So here we're saying if it's an audio XRAW pad, so we're passing audio in the XRAW format across it, then what I want to do is I want to get the convert plugin, or the convert element. I want to grab the pad with the name sync off of it and check to see if it's linked. And then if it's not already linked, then we're going to link this pad that we just found. We're going to link the pad that we just found here in the sync to the pad opposite. Sync pad is the sync pad on the convert element. Source pad is the pad we just found, and we're linking them together. And then we have the same condition for when we find a video pad. Okay, so now what we need to do here is we need to change this up a little bit. So I'm going to do this. Okay, so now what we want to do, I guess, is if the well, do we want to resample here? Let's try and do this first. Well, let's clean up the errors so that this all works. We'll leave this here for now. We'll change up our error handling in a little bit. Okay, so now what we need to do is now construct the first part of the pipeline, and because down here we no longer, I guess we did have the video convert, but we were doing that on the other side of the mixer. We're doing the same thing. I thought we had an audio convert too. We do.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Cloudhawk. Okay, so let's just see if we can get this working, and then we'll start throwing other things in. So the thought here is that now when we get a new input, we need to discover when we get pads, and we need to link them. What do we want to link them to? So in theory, we could maybe link them to the mixer, right? That'd be the ideal case. We might need to put plugins in front of them. Uh-oh. Oh, because this is a closure. What was our error messages? Okay. Okay. We got to put all of it back. Nobody could stop me. Nobody felt like stopping me and giving me a hint before we changed all of them. All right, let's see. What's that one? Okay, right, okay. And then we're gonna have, I don't know what this is yelling at me for yet. Prelude is not satisfied. Video mixer. Oh wait, and this should be video mixer. Right, okay. Oh, what am I doing here? That should be self dot, right? Yeah, okay. All right, help to declare that trait object captures data from argument self. You can add an explicit lifetime bound. I'm not sure what this is. Cannot infer an appropriate lifetime. For what? Okay, I'm slightly confused here. So we have our move that takes place here. Right. It's captured there. What got copied into it? Was that self? Is that our problem? Is that my issue? I might need some help from the audience here that has more Rust experience than me. I'm guessing this is because I'm accessing self from within this closure. Yeah, I am. If I do a, I guess, do I need to wrap that in an arc mutex? Probably. I'm guessing that's what I need to do is probably wrap this in a mutex. And then I'd want to store that on the type, I guess. Right? No. You also have a move closure. I mean, is that my issue here? Is I just need to borrow it? The trait GSP is not implemented for GST pad. Wow. What? Why is it yelling about these? Because I copied those straight out of the other example. Interesting. Okay, so we still have the same issue. Is cloning the appropriate approach here?
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Alan. So I guess this is what matters, right? So is this vector a pointer to the underlying vector, right? Because if I clone self, I'm cloning a copy of mixer. So am I getting a different vector? Or if I modify inputs, is that modifying the vector internally? Right, Mr. Halsey. So that's my concern, is that I'm going to get a copy and I need to actually gain access to these elements, which might themselves be pointers, I guess. So I guess really what I need to do is wrap this in a mutex. But being this is a method on a type, where does the mutex exist? Do we create something like a mutex arc, mutex self? Or what is it? No, that's not right. I guess it would need to be a mixer, right? No. This is where we get into idioms. Because in Go, I would just do something like that, right? I would just do my type, right? So type mixer struct, right? And I would just put a mute sync dot mutex on here, and then I would just use that to control it. But I know with the way Rust works, we need to actually wrap our type in a mutex and get the type out of the mutex. So what is the best way to do this when we're talking about self? Because it makes sense to me elsewhere to do that, right? That arc mutex mixer, right? If like if we were talking about the main code logic having references to the mixer, but in this case we're talking about ourself. I did this a bunch when starting with Rust 2. The problem is that you're trying to pass self to something that may live longer than self. Oh, right, because the closure, we don't know when it will exist. Gotcha. Oh, okay, so it's like a header, crateless. The vector is just a header, so you're copying the header, but the pointers would still be the same. Okay. Options to change this would be to make mixer have interior mutability. Something else should be passing in data to that closure. And what do you mean by interior mutability? Let's see. Rust interior mutability. Let's see. Interior mutability is the design pattern in Rust that allows you to mutate data even when there are immutable references to the data. Normally this action is disallowed by the borrowing rules. To mutate data, the pattern uses unsafe. Yeah, so I'd prefer to try to do things where I don't have to do unsafe code. Because I feel like that's the anti-pattern is doing that stuff. It looks like we can also do lifetimes, but... your members would be arc plus mutex safe, and your mixer could be cloned because of the arc. Oh, right. Okay, yeah, that makes perfect sense. So we're talking about this should really be, right, mutex. Oops. Arc mutex Oh, wait. What am I doing? This is not where I'm declaring the type. Up here. Okay. So this would be an arc mutex spec. That makes sense to me. Uh-oh. What am I missing here? What's the package that's in? Standard sync. Okay. So we need use standard sync, and we need a arc, right? An arc, and we need mutex. Is that right? I swear that's the right thing here. Oh, because I'm missing. There we go. Okay. So now we need to wrap this one as well in an arc mutex. Arc new mutex new. Okay. How to get closures to modify callbacks so you can assign them to a value. Derive clone on the mixer, but it's okay to have everything moved to the new for previewer. Okay, Tej, you're talking about the LSP stuff. Okay, I was slightly confused there. All right, so we need a derive clone on our mixer. Thank you, Mr. Halsey. All right, so then we have all of this. We need to also wrap this in an arc mutex. And I guess we're just going to wrap everything in a mutex. And this will be helpful anyway, because at some point we're going to be calling this like from a we're going to end up calling this from like an HTTP server or something like that too, and modifying it, and we could have multiple people doing stuff. So having all of these wrapped this way is probably super beneficial. Yeah. You may need this on the other members too if they aren't clone. I guess it will be multi-threaded, yeah, when there'll be an HTTP server. Yeah, it'll be multi-threaded because there could be basically asynchronous calls from the browser calling to add or remove things from the mixer. So now we need to do an arc new mutex new. All right. Same thing. Arc new. Mutex new. All right. Mixer. Mutex new. It'll be funny when I finally put this code somewhere to see all of the critiques on the very poor Rust idioms. All right. Wait, what did I miss here? No associated and found new. Oh. New. Okay. What is H? Mismatch types. Alright, so this is just going to be yelling at us everywhere we're trying to use this stuff. So we need to go fix all of this. Okay. So now we need to do a self dot hold on. This is no, the mutex is the thing that's reference counted. So we need to get our I thought we need to. I thought I needed to do something to get it from the reference counter.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, I am Tarenko. I agree with Mr. Halsey. Unless you need to mutate something inside the callback, you don't need the mutex. So we don't necessarily need the mutex for this yet, but we will, because this will have an HTTP server connected to it, where calls will be coming in and modifying the underlying data structure. So wait, so I guess here we need mixer. Let's do a let mixer equal self.clone. There are other mutexes that you can use that do not need the unwrap. The unwrap is due to the fact that some other thread may have panicked when it had the mutex lock. Oh, gotcha. The mutex in the parking lot crate does not need to unwrap if you want to avoid it. No method found. Oh, right. So here we could do mixer.input. Nope. Mixer.lock.unwrap. Nope, that's wrong. What am I missing? No method lock found for struct mixer. Oh, right. We need inputs.lock.unwrap. Oops. .lock.unwrap. There we go. Only 180 errors to go. Yeah, a lot of this is just going to be lock unwraps. Inside the callback. Well, no, not inside the callback. Right? It would be up here at this level that different threads would be calling add input and things like that. You'll clone mutex before. Yeah, I guess I could do that here too, right? Self dot, and that would be fine. And then we'll take this, and then we'll clone that there, and then it inside of here anywhere we reference self. What we really mean is mixer. And I don't think we need that, right? Found for struct arc. Oh, right. So audio mixer is really lock dot unwrap. And mismatched types. We'll come back to you. So this is going to be the same thing. We need a lock dot unwrap. And we need a mixer. What is this? You'll clone the mixer before the closure. Arc clone. Because arc implements deref calling, self.clone could give you the dereference clone function and not the arc clone. It's preferred to use arc clone. So in this particular case, though, each of the fields has their own arc. How's the cloning at the top work? Going for the marathon stream? I'm gonna try. Yeah, I'll probably stream for like another 3.5, 4 hours. I might even stream some tonight and do some Go, so that I can feel like I'm not a moron. So, all right. So arc clone and cell. So what is this? Hey, Milky Dove, what's going on? Oh, okay. So I was right in that sense. Okay. Do you mutate self in the closure? If not, then the mutex is unnecessary. I am mutating things that are held within it, though. Like I'm accessing things on the mixer and mutating them. Yeah. Like here where we're linking these things. All right. What did I mess up there? Source pad. Okay, let's see. All right, how many more hours? Let's see. Or how many more errors, rather? Get boss. Oh, okay. We're missing a couple of other places. So 154. What we really want to do is lock, unwrap. Now we get the bus. So I actually find this really interesting about Rust. So in these particular cases, right, like to me it would almost seem like here you go, Tej, if you're still on. Here's our trap floating window. Yep. And control W does not get me to the floating window. Yeah, control W, no dice. Keep spamming it until it works. Oh, okay. All right. Now how do I close it though?
Catastrophic failure detected.
Nope.
Evacuation protocol has been initiated. Abandoned ship. SOS. Abandoned ship.
Nothing. Yep, nothing. Yep. This is just me spamming control W. Inside the new window? Let's see. Oops. Wait, now there we go.
What is that?
Ah. Do I have something else mapped to it? No mapping found. Okay. What is this? Oh, because I didn't wrap it. So we have an arc, new, mutex, new, pipeline. Okay. Any other errors? We're getting there. So, so what I was saying initially, Vega and Mr. Halsey, is the thing that confuses me with mutexes in Rust is how I'm constantly calling things like lock here, unwrap, is how long do I hold the lock for? Because it seems like, well, when the function returns or goes out of scope, the lock is automatically unlocked. But it also feels like if I call unlock, if I call lock multiple rows, then that also works. Like it realizes that it already has the lock. Is that just compiler smart? Also, does it close if you go back into insert mode? No, it doesn't. Okay, so, ooh, this is interesting. Because here we're actually passing a reference to it. Is that gonna work? Uh-oh. Oh, wait. This one is self. No method named lock found for mutable reference. Mixer. Oh, wait. Other way around. Video mixer dot lock dot unwrap. Yes. Lock returns a lock guard result. Unwrap gives you the lock guard, which when it's dropped releases the lock. Okay. And here we also need our lock dot unwrap. How long is the lock held? This depends on if the function you're calling holds onto a reference to the object. If it holds on to the object, then the lock is held. If the result does not borrow the object, then the lock is dropped after the call. Okay, that makes sense. Now, does the compiler optimize that? Because it would seem to me like constantly grabbing the lock and releasing it would be terribly inefficient. So I'm guessing the compiler picks up on that and knows to just hold it.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Jonito. Okay, we got something going on here. Method not found. Oh, these are all still some of our issues from the locks. We probably need to like wrap these in error checks too. But there it is again. So Tej, what you're saying is it's not your stuff that's broken. You write the best code. Okay, let's see. What are our other errors? Expected slice found array of 3 elements. Wait, what? And then here we go. The trait preload is that element is not implemented for mutex guard. Okay, so that's not going to work. Because we're not actually getting the type, we're getting a mutex guard instead. So it looks like that's our issue across the board. I will not combine locks. If you want to, you can hold the lock and call the function. So this doesn't work the way that I expect it to. Because what we really want to do is we want to pass audio mixer into this array and not the mutex. Right, and so that's sort of my issue, is that I need to pass in the actual audio mixer and not the mutex card. Can I do that, and is it safe to do? Clone the arc. So here we would have audio mixer equal arc clone. I guess that would be self.audio mixer. Is that right? Oh, and self borrowed. Okay, and then so then we should be able to do a okay, so link mixer won't need. We don't have access to that. So the link many is actually an API we're calling. Yeah, so we're gonna figure out something different here. So maybe we were right in the beginning. Maybe I'm assuming that it does take ownership. So I wonder if what we should really do is just pull all of this up a level, where we assume everything inside of here is single threaded, and then the mixer is the thing that we end up wrapping with a mutex and an arc. I mean, that's probably the cleaner way to do it anyway. So then we just have to go back to fixing the lifetime issue.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Augustus Caesar. All right, let's undo all of this, unless anybody disagrees. I'm thinking.
Sir, it appears we have a new
Thanks for the follow, Nomad Pixel. So I'm thinking, and I'll leave this to you all for your Rust experience, but I feel like the cleaner way to do this, because there's so many mutexes, is really to just do an arc mutex on the mixer. And then we just assume inside of the mixer that we're being shared. Okay, yeah. Kratos, yeah, that's what I'm thinking. Because this is just starting to get a little crazy. Actually, I don't know. Can we do like earlier 10 minutes? What does that look like? Go back another 5 minutes. Another 5 minutes. Whoa, I guess we've been working on this longer than I thought. Okay, boom. We're back to our original problem. So now we just need to find a different way of what we really need is access to... Wait, what does it want access to? Okay, right. So we need access to the mixer. The mixer is the thing. So can we do that? Let's see, what is it suggesting? Box plus. Wait, where's it have me add that? After the error. Oops. What was that? Tick underscore? Yep. I'm not sure what this is asking. I feel like we could wrap the mixers though. An anonymous lifetime, so we'll try and figure out a lifetime which works, I guess. So here's my thought. We were wrapping everything, but do we need to wrap everything? I think we just need to wrap our mixer, right? Let's see if we can get this to work. So let's wrap just this. Arc mutex new. We'll start here. Let's just do the one. Right. Where is it? Okay, so here we would do a let. Well, no, I guess we could just do a self.audio. No, clone it up here. Here we would do let audio mixer equal self.audio mixer.clone. Right? What do you mean there's no field on that? Oh, you're gonna look at the GStreamer docs? Okay, cool. Yeah, there is an audio mixer field. What are you talking about? Audio mixer. Audio mixer. Dot. Clone. Audio mixer. Oh, oops. I'm messing up the types here. I love when you try and like quickly do stuff and... Alright, what is this? Can I find
Remind the
mutex?
viewers again, sir. How many years have you dedicated to achieve this level of mastery?
Standard sync. Well, 0 years for Rust, so. Okay, so now we need our arc and mutex here. Okay. So let's see if we can do this now. So we've cloned the audio mixer. And now let's see if we can just do this. Will that work? No. Oh, wait. We need to do a lock unwrap, right? There we go. And I don't know. Oh, because There we go. This should work. And this needs to be this. Okay. So let's just... All right. We still have the same issue. On line 138. So that's not going to work. That's not going to work. Because this is going to be that. It's the same problem we just had. That's going to be a lock guard and not the actual. Yeah, so I think we might end up having to solve this with a lifetime, which still confuses the crap out of me. Because we're in this situation now where this is a lock guard and that does not work. So if we solve our problem with the closure, we break it for trying to pass ownership to here. I also found that Rust lends itself to decomposing types further, where you may have had things in a mixer because they were logically grouped together. Rust is going to favor smaller types where the members need to have proper containment. You know what we might... might need to mutate two data structures at the same time. Okay. Thanks, Dr. Dubenberg. Have a good one. So here's another thought. I think that we can ask the pipeline... get element. I think that we can ask the pipeline for something. Let's go see if we can find the docs for this, because that could be another way around it, right? Because then we could just clone the pipeline. Let's go look up well, I can call methods on these things though, so it would assume like I own them, but I know that I have seen documentation for this to fetch data from a pipeline. Okay, so here's our pipeline. Let's bump the font a bit on that. Why is my dark reader not working on here? Oh, it's off. Why are you off? Oh, we turned it off when we were previewing stuff. Okay, so we can clone it. These are all our trait stuff. Do we not have? Where are the methods on it? Okay, so this is our elements. I swear there was something on the pipeline, or it could have been on. It could have been a method on the GST module. Because at this point, Mr. Halsey, this is where we're using the factory to construct it, but we have to give it a distinct name. And I know that I've seen some code somewhere, it could have been in C, that these are constants, statics. These are all the traits. Okay, let's see. Here's our init. Here's our parse launch, which we don't need. No, I don't see it. Here's our bin to dot. Okay, so maybe we can't. So link many exists on an element, and pipeline is an element. Was it like get children or something? There we go. Get child by name. That's what I'm looking for. And it gives me back a glib object. Do I have to cast that to something? Actually, here, let's do this. It's a detour here, and we're going to back up, and we're going to go into the repo for this, and let's check out the tutorials first and see get child by name. Was it? I thought it was. Let's just say by name. I swear I've seen an example here somewhere. There we go. Yep, see pipeline.getByName. Let's take a look at you. And why is that taking forever? What is... Oh, I think it was building like tags or something. Okay, so yeah, so we should be able to thanks for the follow, Colored Binary. Okay, so that this gives us an option too. So remove the string reference and use string in the function calls, and that will take care of lifetimes for now. Did we have string stuff in there? I thought our issue was because we were calling into... Because we don't have any string references or anything inside of disclosure. So I don't think that that's our issue. In the Rust docs, you can search by return type. Oh, okay. So, in theory, we should be able to, now I guess, remove this again. Let's see. Oops. I have no idea why I just did that. Okay. In the signature of your functions, you are using references which necessitate lifetimes. Is that because of the standard error? Oh, you're talking about here? So you're talking about making that a string? Does that fix the issue? Switcher. All of the strings. Well, this is the only method that's complaining about it, right? Oh, right. We need to df. Okay, let's see. 75. Let's see how badly I've like mixed everything up. So this is still gonna yell at us, but we'll put it back for now. Alright, because we don't need this anymore. Alright, what else are you yelling about? Line 74. Okay, so now we're back to this issue. Oh, wait, line 134. Oops. Okay, so now we're back to the lifetime issue. So add input. Well, we tried that and that did not work. Brainstorming mixer may become a wrapper around the pipeline that can provide borrowed values that GStreamer owns. Yeah, and so that's sort of my line of thinking, Mr. Halsey, is that I think I want to wrap the mixer itself in the reference counter and mutex and just assumed logic. So our only issue here is this closure that does need access to self. But add input and a. All right, let's try it. Oh, and I think Pretzel Rocks just crashed on me. It would then also have your mutating functions. Yeah. So I guess we can do the lifetime thing Crateless is talking about. Let me fix Pretzel Rocks here. The other thought here is that we could wrap the pipeline itself in a lock or a reference counter, and then we could clone that here at the top level, right? So my thought is if we wrap this in a, well, here I'll do the static lifetime, but my thought was if we wrap in a mutex and an arc here, we could clone that, and then we could say pipeline get by name, and then ask it for its audio mixer and video mixer. And then we would theoretically be thread safe, because my assumption is that that code is thread safe in the C world. Yeah, so that was my thought here. Here, let's just go that route. Let's try it. Arc mutex. We haven't wrapped and unwrapped things in arcs and mutexes enough yet today, so all right, use sync. Up standard sync. Arc mutex. Okay. So we're gonna have to like get a lock every time we use this, but we're not like passing references to this anywhere. We're just calling methods on it. So that would seem to me that that would be fine to have that guard. Mutex, new, pipeline. Okay. So then we're gonna have a lot of issues here, but we should be able to say let pipeline equal self dot pipeline dot lock dot no dot clone. When working with FFI code, establish who owns what. It does look like the pipeline owns those mixers. Okay. So then we have this. So now in theory, we should be able to come down here to where self is and just say pipeline dot lock dot unwrap. And now we have this weird issue with that thing again. I don't know what's going on there. Okay, so that should work. Nope. No field audio mixer on type mutex guard. We can't get properties off of the guard. Oops, that's not what I meant to do. I guess I'm still confused on the way that works. So this returns back a mutex guard. So we can't get a property on it. Do you call unwrap twice on that? So we can call methods on it, but we can't get properties off of it. Oh, wait, I'm dumb. This is the pipeline. Duh. All right. All right. So let audio, or let, we need the static pad off of our audio mixer. So what we need to do is say pipeline dot get by name, right? Right, so lock.unwrap dot get by name, audio mixer, And I think that this is an option, so we're gonna have to unwrap that. We're gonna have some error code or cleanup stuff here we're gonna have to do at some point. So that didn't compile. Why did that not compile? Okay, so this is just some places we need to fix because it's not unwrapping. Okay, we're gonna have to find all of those. Let's just do that. Pipeline. All right, okay. Cloning there. Okay, so here we need to do a self dot lock dot nope dot lock dot unwrap. Okay. Dot lock dot unwrap. All right, I think this is going to work a lot better. I mean, aside from the fact that I keep unwrapping things and not handling errors. And that I keep trying to lock self. Lock. Unwrap. Alright. Lock. Unwrap. Oh. Are you removing audio mixer from your struct? Oh, that's a good point. I guess I don't need to track those if I'm just going to grab it off of the pipeline. And really, I wonder if I should even track these things. Let's remove those. Let's let the pipeline own everything. If we need something from it, then we will fetch it off of the pipeline. Where's our outputs push? Yeah. Okay, so what are we looking at? Okay, so we need to do the same thing. Okay, so where's our errors? Here. Okay, so then we need to say self dot pipeline dot right. Is that really how it aligns us? I don't know. Get by name. This is really... Did we name it audio underscore mixer? We did not. And this should be let audio mixer. Oh. That's an option. Let's just unwrap it. We'll do better error handling later. I say that now. All right. What is this? Mismatch types.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Sarah. Okay, so why is this still working? I guess that we're gonna have to just go one at a time and start fixing our errors. So
Yeah, it's super creative.
183. Dot lock. Oh, dot lock. Dot unwrap. All right, one down. Ah, this is actually occurring a lot more than it was. Do I find the type hints useful? Yeah, I kind of do like the type hints. Although now they're gone. Interesting. Yeah, I'm not sure about the lifetimes either. And lifetimes are honestly the thing that confused me the most still for Rust. And I think it was because we needed access to self inside of the closure. Wait, the trait GST prelude is not implemented for GST element. Wait a second, what? And 140. Is that based on the type that audio mixer is? Okay. Unknown field video mixer. Okay, line 73. So we need to copy this because we're going to need this elsewhere. I could... Can I do this? Can I just say function audio mixer and have it return back a GST? Well, actually, what does get by name return? An option element. Okay, so this could, in theory, return back an option GST element, right? Because we're going to do this probably quite a bit, is my guess. Oh. Okay. And so okay. Is that not right? Wait a second. No, because get by name does return back a GST. Hold on, let's see. Expected enum standard option found reference. Consider removing the bar. Oh. There we go. Okay, and then we can copy this and change this to video mixer, and we'll change that to video mixer. Okay. Now this should work a bit better. Then we can call self video mixer dot unwrap, right? What is going on with this hint thing? That's so weird. Like, this is the most I've seen that happen. I need to figure out how to turn that off. Oh, we don't need that anymore. We don't need that anymore. Okay. Line 69. So this would be video mixer unwrap. Self pipeline lock 167 is not implemented for. And line 131 is easily fixed, I guess. So this should be self dot audio mixer dot unwrap. Oops. What is the deal with that? I know what I'm spending my evening doing tonight, figuring out what the deal with that is. Okay. So we still have an issue there. Just.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Finley over. Okay, so let's see. So we still have a lifetime issue. And then we have a... Let's fix this one really quick, and then we'll look at our lifetime issue. Map self pipeline lock unwrap. Wait a second. Get source. Let's open main. I'm trying to remember what this logic was for. Okay, so this is our message bus. When we get a state change message, we're going to get the source of it, and then we're going to compare it to our pipeline to see if our element implements clone. So does that mean what I really should have been doing is cloning each of the elements that I needed? And does that mean I don't need this mutex and arc around the pipeline? You could have kept it on your object and cloning it before the closure and moving the clones in. So what you're saying basically here is I could have done a let audio mixer equal self dot audio mixer dot clone, right? Yeah, I would expect it's a pointer too, because that's the way they do it. So, so let's go. Oops. Where did I just do that at? "30-second lag to streamer." Wow, that's actually pretty bad. So then I guess we would go back to having our audio mixer here. And this would be a GST element, video mixer. And then we would have audio mixer is audio mixer and video. Let's see if this works. So here we would clone those. And then I guess we would just do audio, or no, we would just do audio mixer here, right? Audio mixer. And then get rid of all of this. Same thing, get rid of all of this. Video mixer. Well, that makes things a lot easier. And then I guess we don't need the, we don't need all the pipeline lock stuff. And I guess we need to find all of the places that we do a pipeline lock. We don't need these anymore. Oops. Oops. All right, last one. State found reference. What is that error? All right, let's see. Method not found in mixer. Oh, because we pipeline. We're missing a lock. 137. 137. Field not a method on 121. Oh. There we go. We're compiling again. All of that, all of that, and it already did it. Okay, so that all works. So now the question becomes, does this work? So it turns out that our elements are clonable, and we could just clone the audio and video mixer like we needed directly, and then move the clones into the closure. Yeah, and that's the trouble, like, for me too, like, productivity-wise, is I'm learning both the language itself as well as this, like, library and framework, which isn't like a Rust, you know, specific library. It's like wrapping, and oftentimes when you find bindings in different languages, there's like weird, you know, C-isms that cross over into the binding. And okay, so I think we have this working. Let's move over to our main here, and I'm just gonna comment out this entire thing. We're gonna copy that though. We're gonna create our own new main and see whether we can get. We need our RTMP URI, and then we need our video one too. I don't expect this to work the first time, but it's a starting point. So we need a mixer new undeclared type or module mixer. And I think this is where I get confused about where yeah, learning GStreamer FFI wrapper is another layer. What happens if the element, which is a pointer, is freed in the C code? Yeah, those are the things that keep you up at night. Okay, so what is... Yeah, I'm not sure, and I suppose that's always, you know, something that can be done. Okay, what am I missing here? We have mod mixer up here.
Someone.
Oh, do I need the use?
It appears we have a new follower.
That. Thanks for the follow, Noak Spartan. I always forget this. These are the differences between languages sometimes. Like for Go, as long as it's in the directory, it exists here. So what is my... Most GStreamer plugins, when they allow a get underscore, they return a sort of shared pointer. The wrapper may just call unref object or whatever the G object equivalent is. Code actions on my line 15. I'm not sure what you mean. How do I import stuff from another file? I thought that just happened. Rust import type from file. Do I need to wrap it in a mod? Yeah, that's what I thought. You've got the use. Is that because this one is not... No, mod. Do I need to wrap my type in a module? Is that how we're doing this? Like this? Right. Okay, so that broke a whole bunch of stuff. So I need to bring these into my module. Interesting. So you pull things in at the module level. That's kind of cool. Use mixer. Okay, I'm confused. What am I doing wrong? Oh, wait. Was that it? I wasn't paying attention. It's like I pulled that file in as a mod, and I was calling capital mixer new without prefixing it. So, okay. Yeah, which is what I have now. So, use mixer. Then I can do it. And why is this still yelling at me? Why are you yelling at me? Mod mixer, use mixer anything, mixer new, undeclared type mixer. Why? But if I fully qualify it, it works. Mixer is private. Is it pub? Okay. Now we should be able to. Function takes one. Oh, we need our name. I don't know. Test. Oh, we need to pub all of this stuff, huh? Is it pub function? Pub? Yeah. And Pretzel Rocks crashed again. Pub. I can't wait till like the basic stuff, like just, you know, you don't have to think about the syntax of doing this or importing things and stuff like that. So it'll take me a little bit to get it underneath my fingers, but it'll happen. All right, there's our play. All right. Okay, so now we have this. So now we need to mixer dot add. I thought it was add input. Add input. Add. Oh, because it's we need to unwrap it. So let's just. All right. Add input, and we're going to say, yep, URI is right, and then we're going to say mixer add output, and then we're going to give it our RTMP URI, even though add output is kind of confusing because we are not, we're not ensuring that it is actually RTMP. Let's see. Oh, because, do we still need that? We changed this. This can still be and str. Right? Cannot borrow as mutable. Let mute. Okay. So let's see if this works. Oh, wait, because we never did a mixer.play. Mismatch types. Cargo build. Is the thing I'm doing here for work? It is both for work and for GopherCon, a conference that I organize. Oh, because The number of times I will trip up on that, you'd think I'd learn. Everything is an expression, so it thinks I'm trying to return that. You'd think I'd learn.
Wonders may never cease. We have received a new subscriber, sir.
Thanks for the sub, Nomad. I really appreciate that. GopherCon is Go, and I'm actually rocking a Go hoodie and all of that. So I've been doing Go for about 9 years, full time. So been organizing that since 2014. But I firmly believe in having a toolbox of many languages that, you know, some languages are going to be better suited for different tasks. And for all of this real-time video stuff and interoperability between, you know, the language I'm writing stuff in and the C++ that GStreamer is written in, I think Rust is a much better fit than Go. All right, so our pipeline state changed from null to ready. So is it playing? We didn't get errors. Go has been around since 2009, yeah. Okay, so it says our pipeline is ready, but I don't see any data. So it is quite possible we have something that's broken. Let's find out. Let's just trace this through. Okay, so we have our mixers, we have our pipeline. We're adding our mixers to our pipeline, okay. And then source, oh, wait. We're never adding our source to our pipeline. Nope. Yep. So, okay. So we need self.pipeline dot add source. So we're missing that. I'm not sure how old Rust is. I think they're roughly the same age. Okay, so I don't know why this is complaining. Rust is older? Okay, so I don't know. Let's do this. So we're just missing a few things. Expected reference. Oh, right. Okay, so we forgot to add our source to the pipeline. Now that is added to the pipeline. This closure is going to happen, or is going to be responsible for connecting the source paths of our source to our sync paths on our mixers. Okay, but we also didn't do any like resampling or anything, so we'll look at that stuff. And now let's make sure our outputs are working correctly. So we've got our video converter connected to our H.264 encoder, which is connected to our FLV mux. And now we have a queue on the sync side. I'm just thinking here for a second. We might want to put a queue before our before it goes into our mixer, but we'll look at that stuff later. You know, if everything is not perfect, then we can just work on tweaking our pipeline. But for now, we want to kind of organize the code. Okay, and then here's our audio converter. Okay, so we're adding all our video stuff to the pipeline. We're linking our video mixer to our video converter, to our H.264 encoder, to our FLV mux, to a queue on the outside, and then ultimately a video sync. Okay. And then We're linking our audio mixer to an audio encoder, which is our AAC, to our FLV mux, and our FLV mux is already linked to our cue and video sync. So was that all we were missing, was adding our input? Maybe. Maybe. All right, let's cargo run this. Nope, that didn't work. So these are all warnings. Oh, and we apparently are not setting our in the input. Where's our add input? Did we accidentally remove that? Because we need this logic here. Okay. So this is what I get for looking at the wiki summary. Oh, Rust started in 2006. Okay. To be honest, thought someone said Rust was older than Python, which I was like, huh? Yeah. Yeah, I don't think it's older than Python. Okay, unnamed panic at failed. Failed to get static sync pad from video mixer. Failed to get static sync pad from video mixer. On line 73, okay. But we did get one from the audio mixer? That wouldn't make any sense. How did we connect these before? What were these connected to? This was on the audio converter and on the cue. Okay. So here's where we need to do a little debugging, because we're setting this up slightly different. Those things were already connected. Unwrap your other results. It could have aired earlier. What do you mean? All right, let's do a GST inspect audio mixer. We need to get, we need to request a sync pad off of this. Okay, so we really need to do a dot request pad. I don't remember all of those. Dot get request. There we go. And then I think we need to call this sync u%. I think that's the way, right? Or %u. And where's our video? It's gonna be the same there. And let's see if that works. Oh, this looks good. We got it. So now we're flowing through a mixer.
What brings you to the land of the gatekeepers?
And I can't tell how synced the audio is, but
I'm searching for someone.
but we have a working pipeline wrapped in our mixer type. So from here we can tweak and add buffers and things like that.
A dangerous quest for a lone hunter.
Sweet.
I've been alone for as long as I can remember.
Okay. I've got a lot of tabs. Let's leave at least one of these GStreamers up. That's a Rust docs. We'll leave that up too. Is that the book? That's also the book. Okay. And so we can also look at, for anybody who's like just joining us, we also have the ability, whenever we do this, to generate a graphiz.dot file and then visualize our pipeline. So this was like our original pipeline where the URI decode bin ends up figuring out that what we really need is an HTTP source. And then we end up splitting it and we see the pipeline split in two. So we have a queue that our video is going into and an audio convert. Then we can kind of see the agreed upon format between these two, the source side and the sync side. It's AudioX RAW and it's using S8. And then we can see it continuing out as VideoX RAW and AudioX RAW out of these where we've resampled and converted. And this is our H.264 encoder for the video and our AAC encoder for the audio. And then those things come together inside of our FLV mux. And FLV is the container type. So MP4, AVI, MKV, that type of stuff. And that's what RTMP takes. And then we push that out to a queue for some buffering. And then ultimately to our RTMP endpoint, which is what we were just looking at. Oh, awesome. So RustDoc is local too. That was one of the things I always loved about GoDoc, is just being able to run it locally, especially when you're developing on a plane. Okay, so we've made progress. So now I guess we can, you know what, I'm going to take this file here. Let's see. And I'm just going to copy it to my downloads for now, just in case like there's something in here we need. Okay. So that'll be our example. So our input is also going to, could be RTMP too. Okay, I have no idea how I'm going to unit test this yet. I need to look through the docs for the GStreamer bindings and see whether there's any sort of mock types I can use for there. Because, yeah. And so now I think we're going to have an issue here.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Oleandro. So we have a couple of issues here. So in order for our pipeline to work, interesting. I don't know what. Something's locking up there when I do that.
Someone finds you
That'll
interesting,
teach me.
sir. It appears we have a new follower.
Thanks for the follow, Helga. Okay, so there's a couple of things we need to implement here. So we need some sort of
streams being hosted.
I don't even see a message for where the host is coming from. Okay, so we need some sort of constant source to be played. The reason for this is that the pipeline will end when the video completes. So we need a black screen or something to always be underneath all of our streams so that we can swap them out. Does this make sense? Because basically what would happen is if we tried to start the pipeline, right? And then we removed all of our sources, then the pipeline would say, oh, like we've reached the end of the file. We're just going to go ahead and shut down. And we don't want that to happen. So we need some sort of thing to go in the background where we'll just place our streams on top of. So GStreamer does have a couple of things. So one thing that we could have done is, actually here, I'll show you this real quick. We'll go into the GStreamer things here, tutorials, source bin. Okay, so if you go through the GStreamer docs, there's a tutorial section that you'll go through and you'll create a bunch of example stuff. But the Rust bindings have recreated all of those examples here. So if we look at basic tutorial 1, oh, this is when we're doing the parse launch. So there's actually a function that we can pass the same thing. So if you're not having to hot swap out components, this is the best way to do it. You can use the same string that you would have used on the command line, and then GST parch will assemble the pipeline, and then you have access to it. Is it maybe like 3, 2? Okay, here we go. So here's a test source and an auto video sync. So the test source is going to, well, I'll show you what that looks like. But auto video sync will just find a way locally to play it like SDL. And so if we just use this video test source, then we can do a $target basic tutorial 2, and then this is what we'll get. So you can generate that. So if you just want to test things, you don't want to send it to RTMP, you can just use the auto video sync and auto audio sync so that it'll play locally for you. And then if you don't want to have to try to find a video or something like that, you can just use this. There's also a test audio source, which is just a sound wave. And all of these sources have properties that you can set on them so that you can configure which test source and stuff like that that you want. I don't know. Let's GStreamer test video source. I know there's some options. There we go, animation mode. For pattern equals ball. Flip every second, horizontal speed. Oh, we got a lot of options here. Yeah, I don't see anything with like a countdown. to see if it's synchronized, but oh, here we go. Here's our SMPTE color bars. Checkers, circular, blink. Moving ball. Pinwheel. Huh. I mean, we could mess with this and see whether we can get it working. Let's see. So this is animation mode. I don't think that's what we're looking for. I think what we were looking for is pattern. All right. Oops. Let's see. We always use the beep on second plus timing to compare. Yeah, that's one of the bigger issues with doing video is timing these things. And again, I'm not an expert at GStreamer, but one of the things that appealed to me is like hidden in these streams is actually all of the timing information, and it tries to figure out the clocks and synchronize them just magically. You can kind of customize what the clock is internally. There is some ways of doing that. But so far, it seems to just pass that stuff and figure out how to align them. Because that's one of the biggest pains when you demultiplex out a stream and then do all kinds of things, right? So anybody who's been in this world will kind of understand that. But for anybody who hasn't, when you demultiplex out those things, right? You've got video, which is frames, right? But then you have samples of the audio, which is so many samples per second. Well, so you've got those and they're already kind of trying to align them is difficult. But then you pass them through their own pipelines, which have their own latencies in them. And then you're trying to line them back up later. And so that is actually a really huge pain to mess with. And it's kind of hidden from us right now. And hopefully we don't have to touch that. But yeah, there's a cool FFmpeg tutorial that it's Dr. Anger FFmpeg. I don't know whether it's Dr. Anger or D Ranger or Dranger. I'm not really sure. I like calling him Dr. Anger though. Okay. So this is an interesting tutorial to go through. It's in C, but it kind of talks about the frames and how those things work under the hood. And then in kind of later parts of the tutorial, it'll try to align the video with the audio. And it's a very like naive implementation of it. Like there's obviously some edge cases and things. But if you're interested in understanding how that stuff all works, it's a cool tutorial to go through. It may be broken because it's so old.
Interesting, sir. It appears we have a new follower.
Thanks for the follow, Davey. Okay. So our mixer is working. So we do have this issue. So we should probably figure out how to do that. I'm not sure what test source we're going to use. So let's GStreamer video mixer black screen. I don't know. Do we just put something in the back of it? Okay, so here we'll compare the incoming geometry and frame rate to define the output parameters. Okay. So here there's a video's test source pattern 1. This should show a 320 video test source with some transparency showing the background. Okay, so this is kind of doing picture in picture, which is really cool too. But I do know that we're going to have an issue with...
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Easy8789. Okay. I know that I've run across this and I've seen it in GStreamer before. Well, I guess we could work on the HTTP portion of this too, right? But in theory, if we were like to toss our mixer out into another thread, right, and do the play, or we just threw something out into a thread. Let's try that. And I'm going to have to do some Googling on the thread stuff, but here's the thought. I just want to demonstrate something. Main. So what I want to do is, oh, we don't have a way of removing that output. I guess we should look at how to do that. How do we unlink a pad? So that's our next confusing part. So we might actually need to, right now we're doing this get request pad by template. I think we might need to do this .get request pad. Cheers. Because, wait, no, that's, no, that's what we're already doing. There's, I think there's one we name it, right? Or is this my name? Hold on, let's try this. I want to try video 1, right? Video, or... Because one of them takes a template name and the other one doesn't. Let's see, does this work? Okay, yeah, so it does take a template name. So the issue we're trying to think about right now is we need a way of being able to detach a very specific
Sir, it appears we have a new follower.
input from here. Thanks for the follow, Akshay1994. What if we want to play with this? You know, can you put the source up, or gonna have to copy? No, I'm gonna put the source up. I haven't yet because I haven't really gotten very far with this yet. But yeah, I planned on once it kind of got to it where it was somewhat working, putting it up somewhere. And PR's accepted. Maybe I'll do that this evening or something. I'll push it up, and then tomorrow I can give everybody the repo for it. Let's see. Or wait, tomorrow's Tuesday. I don't stream on Tuesday. Wednesday. Yeah, I totally get that. Okay, so there's another one of these. Let's go to the get pad. And Pretzel Rocks crashed again. I don't know what's going on with this app. GStreamer. And we want to search for get pad. I thought that's what it's called. .get. Okay, so this gets our pads. Get pad template. Oh wait, audio mixer, yeah. So then the question is, once we have a pad, let's just explore this for a second. I don't know, 0. get any information about it. So yeah, let's walk down that path for a second, because that's going to be one of the things we're going to need to do. So adding inputs we've got figured out. Right now we're only supporting adding the input, which is going to like just put them on top of each other. But in theory, we should be able to like talk about like maybe like a Z index to stack them and do some picture in picture. But we'll worry about that here in a second, because we've already got this figured out. How do we remove a very specific, let's see. Sorry, get pads. Okay, so this is the element that owns the pad. Okay. Pads can be unlinked again with pad unlink. Pad get peer can be used to check what the pad is linked to. Okay, so this might be... Okay, so we might actually need to go back to our initial approach here. So I think what we need now is, I think we need our inputs still, and that's going to be a vec of GST element. And I guess same thing, outputs. It's funny how we're kind of like slowly going back to what our original thing was. Okay, so inputs equals vec. Outputs, same thing, okay. And then here, oh, is that going to transfer ownership? Let's see. Self.inputs.push. Mismatch types. Is this what we want? That's going to copy it, right? But it's clonable. So that should, right? Or does that happen by itself? What is going on with you, NVim? We were friends once. So if I pass something in and it copies it, is it the same thing as clone, or do I have to explicitly call clone? Uh-oh. What do you... Borrow of move value source. Is what I really want a reference to GST element? Is that what I'm doing here? Oh, okay. No, that is not what I want. It said lifetime. I'm bailing. That's nope. So I guess we keep cloning, right? So I want to clone here, right? I do want to clone here, and then that'll take away that other issue. Yeah, it doesn't do hex, but the code for the bot is available. So you could do, it does from 0 to 65,000. So in theory, you could, we could write a method to change from hex to that color code. Okay, so that works. Okay, so we're now tracking our inputs. Excuse me. We're going to have some probably sort of output too, because I think that's going to end our pipeline as well. Video convert is the start of it. So we are going to push. Oh, how do we track this one though? Because do we track our audio output or audio and video outputs separately? Because these things don't converge until we hit the FLV mux. But well, I guess we could we'll track the FLV mux for now. And that's gonna be what I'm gonna say. Let's say self dot outputs dot push, and we're gonna take our FLV mux, because what we can probably do is we can just walk this back, right? So if our outputs has this FLV mux, we can keep climbing back, asking for a peer until our peer is our mixer, right? Either our video or our audio mixer. Well, that's going to be interesting. The other option is going to have to be something like this, where it's like, we're just going to use a tuple here, but, or maybe we do something like this, where one is our audio and one is our video. That might make sense. Can I just do an inline struct, like do audio? Is this valid? Like, yeah, that doesn't work. From an unwanted nap. Okay, so we're probably going to need to create new types anyway. So let's just do this. Or wait, is that what I'm missing? No. I'm going to name it anyway, because I think we're going to have some other stuff. So let's just do pub struct output. I don't know. This is going to be an output. This C++, are you asking if this is C++ code? This is Rust. So on our output, we're going to have audio, and this is going to be a GST element. And then we're going to also have video, which is going to be a GST element. Okay, so then and we might do the same thing. Maybe we actually just have that be some name. So what we should really do here then is now we can do a self.push or self.output.push a output, and we're going to give audio the audio encoder, right? Is that the first thing in our chain? Yep, okay. So the audio encoder. And then video is going to be our video convert. Is that the first thing that touches the video mixer? Yep. Okay, so that's going to be our video convert. Okay. Borrow of moved value. I guess we can clone those because they're pointers. Okay. Okay, so that's still working. So now we need to figure out how to find the output that we want. So we have a vector of our outputs. So maybe maybe the better option would be to have a name for this output. All right, let's go find how to do hash maps in Rust. Hash maps. STD collections hash map. Okay. And we need a hash map new and a map insert. Okay. Will this work the way we would like it to? This is a very good question. Because my initial thought was that we could use the URL of the output Let's go that route because you shouldn't be able to output to the same URL twice. So that's what we're going to do. We're going to use the URL as our hash map, or as the key. So what we really want here now is a hash map where we're using, I guess, a string and it was an output. Okay. And we need to fix that to a, oops, hash map new. Okay, so now we need to go to our add output definition. Oops. And we need an insert, and we're going to use the URI. That's going to drive me nuts. I don't know why that's doing it. All right. One of those things I don't want to sit here and fix on stream now. Okay, so that should be working. I mean, we can double check to make sure everything's still playing, but we were just adding new things. Okay, we're good. So now we should be able to, in theory, we want remove output. URI. We're gonna have to go through and fix all of like the error handling and stuff like that for here, but we're just trying to get our starting point. Okay, so what do we need to do? we need to look at our self dot. I'll get there. Outputs. Outputs dot get. Okay, and that returns back an option. So we need to get URI dot toString. Okay. And then we need to match on this. Oh. Let output equal. Alright, we need to match on this. If it is okay, I suppose the better way to do that would be this. Right? Is that more idiomatic? Output, and then we have our match on. We're going to do some stuff, and then otherwise, I don't know, how do I generate a new error to return? I know I've done this before. There's like a macro or something for generating these errors, right? Yeah, I don't want to panic. Don't want to panic. Yep, we're not talking about propagating. Oh, wait. No, because it's not going to be an error. It's okay. So I need... okay, gotcha. So then I should be able to just do error. Can I just pass a string here and say not found? Stream not found. Is that valid? No. I think get returns back an option, doesn't it? Yeah, it's an option. So really it's sum, right? And none, right? But there's not an original error though, right? Because it's just an option. I'm just checking for the existence of it in a hash map, right? I'm sure the hash map examples had.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, 10B2. Effectively, what I'm doing here is I want to have one bit of logic if it's found. Oh, that's right. I've seen that before. So you get like a dot okay or else. Is that just a string? Output not found. Is that right? Oh, I need my own error type. Is there not a way to just create like a new error, like generic error on the spot? Just with a string? Rest create error from string. Hey, look, other people are looking for this stuff too. Standard error. Is that what we're doing? My error. How's it know that that is implementing that though? Oh, here we go. Implement error for my error. Okay. So if this is the normal way to go rather than returning back generic errors, then okay. Let's do that. I would rather learn the like more idiomatic way of doing things. So I guess we can just have like a pub mixer error message string. I don't know. What is the link to this page? I'm guessing this is a question you get asked a lot or something. Okay. So here we're gonna mixer error. Is that right? You just don't do the description bit? All right. Oh, gotcha. Oh, so I guess I need this display too. So is the proper approach to doing this to implement unique error types for each of my things, or is it normal to just have like one error type at the top? Oops. Pub. Struct. All right. Undeclared fumped. Cool setup. I really have to get serious about Rust. Yeah, I'm trying to get more serious about it. You have one enum that implements a bunch of stuff. Enum, my error, GSerror. Oh, that's a fair point. So maybe I'll go that route if I need to. All right, where do I get fumped from? Can't find trait error. Alright, what am I missing? Oh, because I need these. Alright, how about now? Drive, debug. Alright, what is this complaining about? Not expected. Oh. Alright, so where's our or else? So now we can do a mixer error new. What? Let output equal.
Intruder alert. An unauthorized connection has been detected.
Provo, thanks so much for the raid. What's going on? You didn't create a new function? I thought I did. I've got mixer new.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, once DA. What were you working on today, Provo? Okay, where? What did I break now? We are just working on an RTMP switcher. Found standard string, help consider borrowing here. Oh. Alright, was it? We need string. No. Getting close to PRing your new renderer for Alacrity with a 2x speed up. Oh, that's awesome. I'm waiting to see that. That is actually the terminal emulator I am using right now. Wait a second. 190. Did we change something else? Expected reference found struct. Oh, okay. Oops. Oh, where's my cargo watch? Okay. Oh, okay, or else takes a closure. In your new function, new import into string, and then in the new method, you let message equal message into. Yeah, so there is a crate for GStreamer. The Rust bindings are actually really, really up to date. A lot of the folks who work on GStreamer do Rust, so that's one of the reasons why I'm picking Rust for this project. Okay, let's see, Mr. Halsey. In my new, I'm attempting to learn Rust through osmosis while working on this project. Okay, so in my new, you said message impl into string. That is an interesting bit of code. I don't think I've seen this yet. Joke's on you, you're liking it too. That's what I'm here for, to fail publicly so that you can learn with me. Okay, so, and then message into. Wait. Cannot find trait into in this scope. I'm missing something. Oh. I'll have to look to understand a bit better what this is doing. So is this how you kind of explicitly define an interface that whatever's passed in here must implement this trait? All right, what do we got here? So our okay or else is still an issue. What is okay or else again? Okay, it takes a closure. I'm okay with an okay or here. I think that's what I was looking to do. Yeah. It's the same as function new t message t m. Oh, okay. Oh, wow, that's a lot nicer kind of syntactic sugar. Okay, so in theory now we have our output. And then at this point, so oh yeah, Rocker Boot, there's some new sounds in there.
Would you like me to look up a recipe for a light bolognese sauce? It should pair quite nicely with your spaghetti code. Ooh, what color shall we paint this bike shed, sir? I've always been fond of pastels.
Okay, so one of the things I like to do...
Sir, as thrilling as this might be for your viewers, you could simply check the Stack Overflow.
Yeah, there's a... For anybody who's new here, I thought it would be funny to have like a sarcastic...
It's going to take a powerful adhesive to hold this code together, sir. Might I suggest bubblegum and duct tape?
So I always thought it'd be funny to have like a sarcastic Jarvis or something that just taunts me. So that's what those things are. So one of the things I like to do when I'm trying to walk through some of this...
anti-inflammatory agents. I'll have this dumpster fire under control in no time.
So one of the things I like to do is put comments, and then I can kind of hydrate the function based on the comments. Thank God it's not Okay, so what do we need to do? So we have our output. So now what we need to do is walk the climb up the list of parents until we find the mixer, then unlink. And then one question is there any cleanup that needs to be done on GST elements? Because we don't want a memory leak, so I don't know what happens to them.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Orange NS. Why are you still at work? I don't know, McCann. What time is it there? Oh, so the other thing we need to do is remove elements from the pipeline itself. Do we need to do that? I don't know. We're going to find out. Okay, so I guess we'll start there. So we have our output. So the first thing we need to do is output.get. I thought we could get our parent there. What am I missing? that should be the value type. Oh, right. So we need audio, right? Okay. Almost 3 p.m. It is 3 p.m. here, yeah. So here now we have the audio element. We should be able to ask for its parent. And just thinking, we're gonna need some kind of loop here. Just thinking for a second. Having a tough time learning how lifetimes and threads work in Rust. Might be able to have you take a look at the 2 files sometime. Can I ping you on Discord or something? So lifetimes is still something I struggle with quite a bit with Rust. I'm actually pretty new to Rust myself. I've messed around with some basic stuff in Rust a few months ago, and then I just really started to try and pick it up like, I don't know, a week or 2 ago. So lifetimes I'm still messed up. I still get confused by, but there's a few people in the channel that might be able to help a lot more with that have significantly more Rust experience than me. If you have Go questions, that I shouldn't have a problem helping with. Okay, thinking. So we've got our output.audio.getParent. So if we match on that, match. Just thinking. I mean, I guess we could, like, right? All right. So here we're going to get the parent. If we have some, that's the parent. No, okay, so this is what we need to do. We need to do let element equal output.audio here. And then we would have element.getParent. All right, and here's our parent. So if we have a P, then we would do element equals P, right? Because we're climbing up. And then we'd loop around and we'd try to grab that parent. If we have none, then we're going to unlink here. I think that makes sense. And then we obviously want to break the loop. I should get a Discord. Do I need a Discord? I feel like I'm in enough Discords and there's a sufficient overlap with people who are in here. Expected. Wait, 206. Am I missing a parenthesis? Yeah, well, I mean, there's a bunch of Rust Discords too. Like, there's a Rustation Discord too. What is this error? Expected parenthesis. Try placing this code inside a block. Why does that need to be in a block? What am I missing here? Oh, because that needs that. And we need a counter for the number of times I've been burned by the semicolon thing. Oh, no, is that not it? Expected found. Wait a second. Is this just a 4? Is that how we just do an unbounded loop? It's something with the match statement. Oh, because the match statement is... No? All right. Found GST object. Ooh. That's not good. So that might not work the way we thought it would. Do we have a way of casting that? Yeah, GStreamer is in C++. So now we need to figure out how to get our element from here. Rust FFI meets C++ object inheritance. Yeah, I've seen some stuff from one of the GStreamer creators or something at a conference that was talking a little bit about trying to recreate some of that stuff. Let's see. So we can't walk up and get the parent. Isa. So this looks like how we might be able to do it, right? I'm not sure how this Isa thing works.
This time, make sure they're all dead.
Into. Okay, so that doesn't work. They seem to have a cast trait and some cast downcast, maybe? Or would it be up? Trait found GST object, GST prelude is a GST element is not satisfied. Why is it not satisfied? Because that's what we want. Mismatch types. Oh, we get a result. Perfect. Perfect. Oh, wait. Okay, so let's wrap this. in a block. Because now we need to kind of like do like a nested match. Okay, so in this particular case, I guess we can do a trying to think of how we want to handle this, because I mean we could just do a no, we don't want to return. So downcast subtype only exists if the trait can downcast subtype exist. It's going to take me a while to like learn about all of these different traits and what they provide. I feel like a year. Okay, so we need to handle this. So let's roll with this for a second. Okay, so this is going to give us a result type. And so if we match on that, actually, you know what? We can just do that. Wait. So if we match on the downcast, if we have some, no, it's a result. So if we have okay, we can just reuse P. If we have okay, then we set element equal to P. And then if we have none, then we break still. And that would mean what is this? Is that syntax wrong? What am I missing here? Expected enum standard result found. You need a block. I thought I had one. Some P, right? That's the block. Here. Ah. No. I mean, that fixes one issue, but, what do we complain about? Expected GST element found empty. Expected standard result found enum standard option. Oh, right. Because this is, wait. Okay. No. Some. Because they're both options. None. Right? Oh, that's a result. Error. We don't need that. We're just going to break. There we go. And this should be okay. Is that because... Does that not matter? Okay, so I guess we just leave it set to itself, maybe? Alright, element equals P on line 199. Oh. I'm dumb. Cannot move out. Output shared. Why are you assigning 2 times when I should only return P? Yeah, it was just an artifact of what I was doing. The line of thinking before. Okay, so... move occurs because output audio has type just the element, which does not implement the copy trait. Help consider borrowing output here. And I guess that would mean I would need to do this. Right. No. Is not implemented for okay, so that does not work. Do we need to clone it? There we go. Oh, so what's the difference between doing a mute here and then doing it here? Man. These are some of those things like I need to try to understand. I mean, cloning seems to work. All right. Let's make sure this is still playing. We're getting closer. And I might build a helper function for this too. Okay. So, but for now, because the logic's going to be the same for both audio and for both audio and that. So this is going to end when we can't find any more parents. But we also have so this is going to climb until we can't find any more parents.
It appears we have a new follower.
Thanks for the follow, Digimon. So we do have another scenario here. So I'm actually going to come out of here too, because really at this point, element is the topmost parent, right? So now we need to see whether that let's put a block here too, and I want to debug this. Oh wait, I always forget about that. The macro allows us to do because it returns back the same value, right? So that should work. Oh, but we're not calling this. I guess what we can do is inside of play for now. How do we want to do this? Let's just open up main for now. Source debug, our source main, and rather than play, let's just do a mixer.remove output, and we want RTMP URI. All right. So we're getting the GST pipeline. So that's not what we were expecting. Oh, wait a second. I'm dumb. Oh, wait, no. Remove output. Remove. Okay. So we're getting our outputs. And we push the audio encoder. So... Oh. So we need to check here because maybe our the peer... Wait a second. So I only saw one here. So is the parent of that really the pipeline? Okay, so that... Maybe that wasn't the method I was looking for? No, that we want to get peer. We want to get peer, right? Oh, we wanted to get the pad, and then the pad has the peer on it, right? Okay, so you know what? Maybe we're going about this the wrong way. Maybe what we should really have here is the pad, right? We want the topmost pad to unlink. Otherwise, we're trying to find... So we need to track it from one side or the other. We either need to know which pad it is at the mixer, or we need to know which pad it is at the output side. All right, let's just look at some docs for a second and see what we can come up with here that might be a better solution to this. Ideally, what I'd really like is I know that we have this get so like here, right? So we have the ability to get these pads and get their name and all of these things. So what I want to know is, so we're requesting this pad here based on its template, but can we name it? Because then we could maintain a mapping of our like an identifier with its pad. So let's look around at the API just a little bit and see what we can find for this. Pad get parent will retrieve the element that owns the pad, which is fine. Get peer, but we don't have a pad. At the source side we do. Get source pads. Get sync pads. So we could get them and we could iterate over them. But what information do we have about them? It looks like there was like a get current caps. All right, so it looks like we need to look at this pad, ext. Get allowed, get current caps. Okay, so we can't call get parent element on the pad itself. Okay. Get single internal link. This is Chromium. Yeah, this is Chromium that I'm in right now. I have been playing with Edge for Linux though too. Hey TS Joss, what's going on? Oh, cool. I'm gonna have to play with that a lot more. Okay. So get stream ID is active, is blocked. So I think that query caps. Oh, wait a second. No, because we have, I'm just looking at this the wrong way. So, oops, in theory, we're just sort of skipping a step here. So we're getting our audio. Where are we setting the output? Okay, so we're getting the encoder here, right? But if we do a GST inspect, what was it? FDK AAC, right? So oh, wait. Yeah, we need FDK AAC enc, right? So here we have some static pads. So we have the source and the sink, right? And so we want the source side. So in here, right? Get static.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Injection XYZ. Yeah, they did release Edge for Linux. It doesn't have all of the features, like some of the account management and syncing of profile data and stuff like that. I think isn't all quite there, but yeah, it's it's there. Okay, so what we want to do is remove output. Let's see. What we need to do here. Wait, no, that is a pad. Oh no, because I changed it to pad. Oh. I need to go back and fix this. So this is an element. Although I do feel like maybe a pad is a better option here. So let's go to remove output here. I think what we want to do here is actually, I'm just going to leave this code here and we're just going to kind of play. So we take our output, we get our audio element. Then what we want to do is get pad, get static pad, sync dot. Oh, we had this as an example. Good thing I copied that over to my downloads. Right? Was that what I had in there? Get static. Yeah. So we check if it's linked. And then, yeah, here's how we're going to get the pad type, right? Okay. I don't think I have an internal tested version of it. Wait, I might actually have an internal tested version of it. I forget which things are public and which ones aren't. Okay, so here's what we're gonna do. So, so if we say let sync pad equal that's I'm just gonna leave this expect here for now. Okay, so we might have to like abstract this out a little bit, but I just want to see whether follow along through this. Okay, so we're gonna ask for the sync pad.
It appears we have a new follower.
Thanks for the follow, Alan Darity. Okay, so now if we grab the sync pad, we get the caps off of it. Grab the struct off of that, then we should be able to get the name of the pad type. Do we care about that? Sure. So we'll check to see if it is an audio one. Then we can get, we check to see if it's linked. If it is linked, then we are interested in unlinking it. But we have another check that we need to do. Wait a second. So that's our sync pad. We know it's only going to have one because of the way it connects to the mixer. Excuse me. Okay. No, it's not NDA. Besides, it's just me and what, like 50 or 60 of my closest friends. You all wouldn't tell anybody. Okay, so just walking through this, we grab our sync pad and we're just looking to see whether it's the audio one. But I feel like this doesn't matter. So then what we really need from here is, I don't think we need all of this. We don't need all of this because we're going to assume that you were smart enough to know to connect all that. We eat brunch together at Began's place every Sunday. Exactly. We're all going to show up there on Sunday. Okay, so we have, at this point, we have our sync pad, right? I'm curious whether this is going to work. I'm going to debug this out because at this point I want to clarify that I'm getting exactly what I think I am. Can I not call debug that way? Oh, sync paid. All right, cargo run. Okay, here we go. There's our pad. Okay. Oh, I do think we're going to need... I think... I'm going to bring all of this back because we might need to call this... We might need to call this to get more information. Okay, so we have our sync pad. We know that we have our sync pad. So what we really want is our sync pad's peer. Get peer. Okay, so we get the peer, and what are we doing? Can we unlink? No. Oh, wait. Ooh, okay, so we can unlink it, so that's our sync pad. Sync pad. Is that it? Is that all we need to do? Well, you're yelling at me for something. What are you yelling at me for? Oh, because it's not a reference. Okay. Is that all we need? Because we know what our own sync pad is, because it's the sync pad on this. And I mean, this may change based on what people decide to connect, especially when we start getting into like a T and things like that. But we might refactor that. So some of this might even not be, we may not even need it anymore when we connect the T. But for now, we're assuming the element that you put in that output struct is the topmost element in your chain, in your pipeline. So, and that it has a static sync pad, and then we unlink it from the mixer because its peer should be the mixer. You need to pass in when you're unlinking. So yeah, no, because this is the peer, and we're unlinking the peer from the sync pad. Oh, okay, you just didn't see that part. Gotcha. So in theory, this works. Oh, we have a way we can test this. So, oh, you go away. If we remove this output and then we do play, it should not work because our pipeline isn't complete. Internal data stream error. And we stop streaming. And that is because we don't have an output. So if we bring that back, this should run. No, I appreciate you speaking up, Mr. Halsey. You're catching a lot of stuff that I'm just completely unaware of. I really need to do some more reading and studying on a lot of this stuff. Okay, so that looks like we now have a way of removing outputs. So I guess our next thing would be we could experiment with, yeah, I need a shout out thing. Let me. There we go, Rocker Boo. My bot is just really slow. Okay, so One thing that we can do from here is we could start looking at, there is a an additional type here, or an additional element that is called a T. And that allows us to have one sink and then a number of sources. So that effectively allows us to split our stream into two. So, because our mixer is only going to, a mixer is going to allow us to take two things and put them together into one, and the T is going to go the opposite way. So the mixer is how we're going to be able to get multiple inputs and sort of switch between them. And then the T is how we could effectively send it to multiple outputs at once. Okay. I was gonna try and stream some Go tonight, but holy cow, like I'm already losing my voice. Okay. So it's really on the T that we're gonna remove it, but it should still work. Let's see. Well, where are we referencing this audio mixer and video mixer from? Oh, wait. We forgot one. Remove source, or remove output. We don't even need all of this craziness that I just... and we still do need to discover if there's any type of cleanup we need to do on those elements.
Would you like me to look up a recipe for a light bolognese sauce? It should pair quite nicely with your spaghetti code.
I need some garlic bread too. Okay, I can just chain this, right? Expect, right? Get here. Yeah. Unlink. Just playing with sort of how these things work. So that's not me. I had somebody do that for me. Yeah. So that's sort of the thing. I thought it would be really funny to have like some sort of like sarcastic, you know, robot-esque AI that just taunts me. And it's pretty funny. And the audience does a good job of using it. Okay, what did I break? Method not found in option. Oh, because we didn't do an unwrap. Right? ThinkPad not found in the scope. Oh, wait. That's why I had them separate. Okay, so we need to copy all of this. Actually, let's just do this. I'm going to copy all of this. Detach audio. Detach video. Okay. So here, video, and it should work exactly the same. Failed to get ThinkPad from audio.
Sir, if I may be so bold as
Video.
to speak for the viewers, you clearly seem to be enjoying yourself, but we haven't got all day.
A mind as big as the universe, and I'm watching you code. Yes, Krasnik, this is Arch and i3. Okay, so this should work. So I guess maybe before we get too far, maybe what we should do is maybe look at the T. because I think that's what we're ultimately going to do. Oh, right. We needed to see what all touches audio mixer. Okay, and that's where we create it. And that's only in the sense of connecting the source pads. That's okay. So then what we need is let's see. I think when we create the pipeline, what we need to do is create T's. Right? Yes. Output. GST. Oh, wait. We might need to put that. I love i3. I've been using it for years. Well, aside from like I took a 6-month break and decided to recheck all my assumptions. I used Linux since like 2002, Linux on the desktop, and I decided for about a 6-month period to recheck my assumptions because I hadn't even really used Windows, to try with like VS Code and WSL and all of that. So I did that for a few months. But aside from that, I've used i3 for I don't even know how long. I've tried Awesome and DWM. I've not tried LeftWM though. I am using Alacrity, the terminal emulator that's written in Rust.
We have a new follower.
Thanks for the follow, MJ. Okay, so we're going to have a new thing. So we need to create a T. And this is a T. And I guess we'll just call it T. We only need the one. So we are going to need to gain access to this. So let's, I don't know, we'll call it T for now. Output probably makes sense, but output versus outputs, that's easily messed up, but it's a statically typed language, I guess. So we'll just set that here for now. And we need, T is a GST element, because apparently everything is a GST element. Okay. So now we have that. We do need to link this though. So we've got our audio mixer, video mixer. We need to add our T to the pipeline, and then we need to pipeline link no. Is it link many? No. What am I missing here? Oh, it's just, it's a static thing. All right, and so we need to link our audio, or, oh no, we need 2 T's, because we need an audio T and a video T. So audio T, video T, audio out, video out. And do we need to track outputs? If it helps to organize the types a bit better than GST element everywhere, you can create an enum for the different types of or tuple struct. A TV and a TA. What do you mean, Mr. Halsey? Oh, I got you. TV, TA. I think like the fact that it's a T element probably isn't as important as recognizing that what its purpose is. So this is a video out. Oh, no. Video out. And audio out. Okay. Your suggestion is bad? Yeah, you've been here for quite some time, Mr. Halsey, and I have not heard one bad joke. A question to everyone, what is the best way to document REST APIs? Anyone use Postman and API docs generator? I mean, I'll use, what do they rename it to? Now I'm gonna lose it. Somebody will think of it. Swagger. Yeah, but they renamed it to something, and I'm trying to remember what they renamed it to. Open API. That's right. Okay, so we have our audio out, we have our video out. So now, oh, wait a second.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, small brute. Okay, so here we're going to do our, wait. We need 2 of these. So we need our T audio.
Someone finds you interesting, sir. It appears we have a new follower.
T, oh, it's still the same thing. Audio. All right, let's audio T. I think let's be consistent here. Audio T. Thanks for the follow, Colin Loritz. Video T. All right. And then video T. Okay. So I heard the police were called to a daycare where a 3-year-old was resisting arrest. Nice. Okay. Let's see. So here we need our audio T and our video T. And then we can do here audio or video T, audio, audio. All right, so now we have a T element. It is added to our pipeline, and we have linked. Wait. What is all that? Link many. Now I'm really confused. Why is this wrapped in a link many? I think I pasted something in the wrong place. Because this isn't linking anything.
Sir, as thrilling as this might be for your viewers, you could simply check the Stack Overflow.
So we are working on an RTMP switcher so that we can have multiple inputs and outputs and we can switch between them. So think about like, I don't know, maybe like an OBS, but it can pull in feeds from multiple people streaming and seamlessly switch between them. So this is all jacked up. So now I feel like I need to roll back in time because I clearly messed something up here. Because that shouldn't look that way. Oh, yep. So that's where we went wrong. Okay. Wait. We still want that link many. All right.
Catastrophic failure detected. Evacuation protocol has been initiated. Abandoned ship. SOS. Abandoned ship.
All right, now we get to go back and do this. Audio out is going to equal audio T into video. Video. All right. Audio T. Oops. Does anybody ever do that where you just get like slightly shifted off your keyboard and then you just jack up everything you're typing? I do it all of the time. All right, so there's the creation of our elements. So let's go back and our audio T and our video T. Okay, and then now we need to do our linking. Oh, that's what happened. That was sitting there and it decided to fix it for me. Okay. Happens all the time when you're in the middle of an interview. Let's see. This is way over my level. No, small brute. Nothing is ever over your level. Never, 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 never. That's the best way to learn is to adopt some projects that are like a bit over your head and you figure them out. And I'm not an expert on this stuff, but we're all learning together. And I am happy to explain any concepts that I do happen to know the answers for that are related to this stuff to help get you where this is on your level. Okay, so we need to link our audio mixer. And if you watch the prior VODs, they're still here on Twitch, but I've also archived them to YouTube. I walk through some of this stuff and we go through some very, very basic examples before we kind of pull it out to this. And I kind of explain how some of this stuff works. All right, so we need to link our audio mixer to our audio Yes. We need to link our audio mixer to our audio T. And then we need to link our video mixer to our video T. Okay, and then the audio is going to connect to the audio mixer, which is fine. It's the outputs that we need. So now when we go to our add output, we are currently linking to the video mixer. So what we really need to do here is actually do video out. And then same thing here, because we've linked. Wait a second. Is that right? No. Let me rethink that. Now I'm starting to confuse myself. Okay. So here we have our audio mixer and our T. We want the T to be connected on the outside. We want the output of our mixers to go to our T's. And we have accomplished that. Okay, perfect. Now, in our add input, we're creating this input, and then we are connecting when we find when we get a notification that a source pad has been added. Then we get a sync pad from our mixer, which is on this side, and we connect the two. Okay. So now is the output. So our mixers are flowing into our T's, which are going to split them. So at this point, we don't care about the mixer. We care about the T. So we want video out. And then same thing here. We want let's see if this works. Ooh. Okay. So we broke something. Oh, because we're removing our output here. Oh, if this works, I would say I'm going to do a backflip, but let's be honest, I'm not going to do a backflip. All right, sweet. So now, in theory, so a little bit of history. In my 20s, I was a big motorcycle person. There's some models up there of ones that I've owned. And I got into a motorcycle accident. I was hit by a car, and I broke my femur in 12 places. So I don't think there will ever be a day I can do a backflip again. Okay, so we need another RTMP endpoint. So we don't have a way of previewing this, but we could stream to the same place. Let's see. So if we do we need to do a sanity check. Add output. Oops. Add output, because I don't know what's going to happen here. So to do, ensure that this output URI doesn't already exist in the map. Throw error. Okay. Where was the other thing we needed to do with the remove? I'm going to add to-dos here because I don't know what the answer to these questions are. So I want to track those in to-dos. Okay. So now, in theory, we're going to crude nasty code this. Okay. So we're not going to be able to watch it, obviously, but what we can do is, oops. And I do the same thing I was just putting in a thing for. Okay. So now if we run this, what should happen is this is going to play. And then once it starts playing, what we can do is we can look in this HLS here. This is where the manifest file for our initial one is, but we can check stream key 2. Ooh, not found. Okay, so I know what the issue is. I know what the issue is. I think. No. That should be fine. It shouldn't be an issue with... Wait a second. Okay, so what's our issue? Let's look. So when we add an output, for each one we're creating this chain. For each one we're creating the chain. Oh, wait a second. So this might be an issue for us. All of these things are named in our pipeline. I think, okay. So I think we're creating duplicate things here. And I'm actually starting to wonder if the appropriate thing to do here is to build a pipeline. Like basically to take an output and turn it into its own pipeline. And then we attach that pipeline to the T. Well, I guess it would be 2 pipelines, wouldn't it? But let's see. Yeah, so the first one works. So my guess is it has to be like the names. Although we don't get any kind of errors or anything from it. Which is interesting. Well, no. That's not true, is it? Because we're just throwing away the errors here, right? So in theory, this could be throwing away an error. What's the best way to print that out? Just debug? So we're just sort of swallowing errors here. There we go. Yep, failed to add elements. Name video convert is not unique in bin test, not adding. Okay. So we have a couple of options here, right? So the first one is that we can either create a pipeline out of all of this, and then we can attach the pipelines, and then our unique names occur at the top, or we come up with a unique identifier or name or something like that for the output. And then we prefix this name with that. And I don't think we don't want to use the URI. I mean, we could hash it and use that. What do you use the names for debugging? No, so what it appears is that, remember how we said we could ask the pipeline for an element by its name? That is unique. So we can see that our second add is failing to add the elements because the name video convert. So these names have to be unique in the pipeline. So our options are either to create a pipeline for each, because a pipeline can also be an element in another pipeline, or we can come up with some sort of prefix or suffix for these. And I'm starting to wonder if maybe the separate pipelines might actually be the better approach. Because then we could just name the one element in the pipeline based off what the output is, right? So it would be like our audio mixer is connected to our audio T, which is connected to our... Thanks for the follow, Petter Master. So then our audio T would be connected to our, I don't know, output 1, right? And then this itself would be, you know, the video convert, X264, right? It'd all be embedded in there. Yeah, so yeah, they are cheap. I don't think that there's any disadvantage to doing it. The advantage to doing it is that we don't have to have like these unique names for each and every one of these. Like our pipeline might get really hard to find stuff in when really we don't really care about all the individual elements of this output. We care about we just care that we connect our audio and video T's to their respective ends. Am I even ready to do this refactor right now? So RTMP stands for Real-Time Messaging Protocol. And if you have ever streamed to Twitch or Facebook Live or YouTube, that is the protocol in which you are pushing all of your audio and video. And that is contained inside of what's known as an FLV container. And inside of that are multiple streams multiplexed together, audio, video channels, things like that. And I'm probably going to call it quits here in just a few minutes. So we could also just sort of stop for a second and I can answer any questions people have about the project or audio and video or GStreamer, the things that I know so far. I'm also happy to do that, being that I'm, 20 minutes or something, I'll be done. Can I toss the code up? Sure. Let me create a GitHub repo for it. Oh, the UI hates me. What will I use this for? So it's going to have two use cases. One is if it's done in time, I plan to use this for GopherCon, which will allow us to switch back and forth between MCs and our speakers and have sort of like a seamless experience there. And the other thing that it will be used for is for Microsoft's Learn TV that they have in their docs section. Wait, no, that's Microsoft Learn. That's not what I wanted. Did I? Oh, Learn TV. I swore I said TV. There we go. So they've kind of got like this embedded thing, and there's a scheduler that schedules videos combined with live streams, and they're kind of interlaced in between each other. As well as right now, Microsoft Developers Twitch account has multiple people who stream to it, and there's like constant managing of stream keys and what if somebody pushes in when they're not supposed to, and all of these things. It'd be so much easier to have a scheduler say, well, Mr. Halsey's up at 1 p.m., so we spin up an RTMP endpoint for him at, 12:45, and then the scheduler says at 1 p.m., we switch streams over to that one. I'm currently using Chromium, but I also have Microsoft Edge for Linux that I've also been playing with. All right, why can I create a repo here? Hold on. All right, we need a name. I'll call it RTMP switcher for now. Okay. Where's our repo? What's that? What sounds fantastic? The just kind of the use case of seamless switching and stuff. Yeah, and so the other thing that this will be used for too, Mr. Halsey, is if we look at our diagram here, this is the scheduler that the switcher is going to use as its system of record. It also allows us to create kind of like a declarative state so that if the switcher dies, it doesn't take down everybody, right? The switcher can pop back up and it knows, well, at 1 p.m. I was supposed to be on streamer 1, so let me go fetch their RTMP feed and start pushing it. The other thing it allows us to do is when we put people in a schedule for a live stream, if you had a pre-recorded version of your talk, we could also track that with your scheduled stream, and then we can measure the bit rate here. And if your stream drops and you're gone for some period of time, we could go fetch the video recording and we could seek to roughly the current position that you were in time in your talk and sort of fall over to it. And so those are some of the like end goals. The other things, it's like automatically adding lower thirds, things like that. It'd be really cool to just have all of that be seamless. Okay, so let's get in at this. I guess we need a git ignore because we're gonna want to ignore our target. Oh, target's already in there. All right. And I'm gonna add those dot files to playing.svg and dot, because we're gonna generate those quite a bit. All right. Git commit start of mixer. Git remote add origin git at github.com:Eric St. Martin /RTMP switcher. We need a cooler name for it though. Git push origin master. Okay, so now RTMP switcher. All right, everybody. And I will happily take any pull requests, both cleaning up of code and things like that, because the end goal of this is I would like this thing to exist more than I would like to create 100% of it. So I will happily take any sort of pull requests people have. File issues. If you have ideas for features, totally file those too, because the goal is to hopefully have this be like a long running project. And I would love to have, like, I want to build like a whole suite of stuff where eventually maybe we can just have like a deploy button so that conferences can just hit a button and deploy this thing out. And even maybe even build a, there is a, is it own cast, right? Yeah. So this is written in Go, but there's also, this OwnCast thing, which provides chat in video. So we could also pair the two together so that a conference could just run all of this somewhere in the cloud and not pay $20,000 to do live video for their conference. It's just insane what these people are charging. So, Crateless, could you drill down a bit on the boxes on Excalibur? Absolutely. So OBS is pretty straightforward. So what these streamer things really are is this whole thing we've been using to preview this RTMP feed. That is what is represented in this box. So it's basically Nginx running the RTMP module that's receiving an RTMP feed from OBS. And this one is also repackaging it into HLS so that we can view it in this web player. But that's not needed there.
It appears we have a new follower.
Thanks for the follow, Duscalineros. Okay, and so we'll probably leave this here. So if you wanted to preview your own stream, or if, you know, somebody viewing the switcher thing, and if for anybody who wasn't here, I can show where I'm at with the UI, because there's going to be a whole production UI for this too. So that's what that is. And so videos is really just, this could be anywhere, cloud storage or something like that. Videos is just where we can fetch videos from. That could be a backup stream for if the stream fails here and we want to fall back to it. Or it could be this scheduler here can have a playlist of videos to say, well, you know, at 12 p.m. this video is playing. At 1 p.m. this video is playing. At 2 p.m. this streamer is going to be on. At 3 p.m. this streamer is going to be on. At 4 p.m. video. And so you can kind of interleave those things. And so what we're building right now is this switcher. And the switcher is going to go out and fetch it. Right now we have it fetching a video, but we could easily pass it an RTMP stream, and maybe we do that first thing on Wednesday. And it's going to fetch the stream, and then it's going to push it out. And the logic we just started finishing working on is this split here, where we can say, I want it to go to both Twitch and YouTube. Any overall dependencies needed for packages? What do you mean dependencies for packages? Like crates needed to build this, or oh yeah, you're going to need to install all of the GStreamer stuff. You're good, bad, ugly. Yeah, you're gonna want all of the GStreamer stuff. Let's see. I'm on Arch, but let's see. Pacman QQM grep GStreamer QQN. I always mix the two of them up. Is that oh, it's gonna be GST. There you go. So you need, if you're on Arch, this is what you need. I don't know whether you want to clip that or something, but yeah. So that should be it. GStreamer. The VAPI we don't need yet. We do plan on, and if you want to run some of the front end stuff, Qt would work. But eventually we're going to do the transcoding using the. So right now our mixer is using this X264 encoder, which is a software encoder. But the intent is to actually at least have the option of saying that you would like a hardware encoder, so that if we ran this on like a GPU node, we could do that. Can I toss that into a README? Sure. Tab new. README. Let's pull over our link to where's my link. Okay, so I'm gonna, oh actually I think I can save that as a image, but I'll leave that as an exercise to the readers. All right, so RTMP switcher. This project will serve as a way to an HEVC output. Yeah, and so that's sort of the beauty of all of this is to hopefully expand and have all of this stuff just work. Here, let me paste all this while I'm thinking about it. So I don't even know if editing services is needed, but I'm just gonna copy everything that I have. Okay. Not packages Not all of these are required yet. If you have all of these, though, you shouldn't have trouble using any documented elements. Okay. I'm just gonna... I don't know. I should add a license. Yeah, yeah. Oh yeah, status. We need like a status YOLO. All right. All right. It might eat your homework. Exactly. Okay. So, let's see. I use Pac-Man. So your package names may differ. Okay. This project will allow you to simulate a production video switcher with virtual streams, allowing multiple streamers to broadcast to separate RTMP endpoints and seamlessly switch between them, as well as pre-recorded videos. Future features planned. Transitions fell over to pre-recorded versions of talks, hardware encoding, multiple outputs, restream. Did I find the closing thing, or am I still missing one? Okay. What other stuff did we talk about? Oh. Lower thirds. Picture in picture. $14 now. Oh. Gotcha. All right. Oh, right, yeah. There we go. Tooling to deploy alongside own. Where's the link to Owncast? I may additional documentation once I get it working locally. Awesome. I like, yeah, even documentation. If somebody wants to like take the link to that, take the link to the sketch that I did and just export it as an image and upload that into there and all of that stuff. Yeah. If there's something that's confusing that I've explained a bunch of times that would make sense to put in here, you know, totally. All right. Anybody have license preferences? I know a few of you have expressed interest in using this for some of your own use cases. Is there anybody here who has any preference or objection to specific licenses that are going to prevent you from using it? Yeah, MIT is typically my default rockaboo. What? Oh, it's already in there. Oh, I should have generated this when I did it. MIT license. Those loopholes for preventing cloud platforms from making a service for it? What are we talking about? You're saying MIT does have loopholes or does not have loopholes? Oh, I left that debug stuff in there. Oops. Oh, MIT does, yeah. Yeah, and that works for me too because we're kind of going to use this too. I don't know whether I'm just going to put me here. I don't know whether this is supposed to be Microsoft or not. I don't know. We'll change it. I mean, I'll move it to another repo or something if Microsoft wants it underneath their GitHub or something. So, I suppose I should find that out. Okay. So, are we all covered? Base is covered now? README. Alright, wait, yeah. Commit. Add MIT license. Alright. It is up there. There is a license. You may do as you wish. I like MIT so that I can create a company that charges for services only 10,000. I mean, at least it's half of what everybody else is charging. I mean, so yeah, I personally, for me, for license, I like the most permissive, just because like if I'm working on open source projects, I just believe in like just the altruism. Like I'm not, if I'm doing it in the open, then I'm doing it for you to have for free, right? And I want the most amount of people to be able to use it and contribute to it without there being any problems. So open source projects are only fun for a very short period of time if you're the only person who works on it or uses it. Yeah, actually, this actually probably is a really good thing for businesses that are doing all of the online video streaming. That is true, right? And it won't surprise me when it gets to a certain point and stable to see people using it, because let's be honest, like everybody that provides a video streaming platform right now basically provides you the same thing Twitch does, right? Like, well, we'll take your feed and we'll transcode it and we'll push it out to the CDN and scale and maybe synchronize chat and stuff like that. But there's nobody really doing like production level stuff. Like if you actually had a video engineer or producer there's, yeah. I'm sure there's some really expensive hardware boxes you could buy that would do that. Actually, I think what's the one? There's one I'm thinking of, the TriCaster and some of the Blackmagic ones that do Skype. Those probably have some of that stuff. You want to feed your kids, can only be so altruistic. So, all right. Does anybody have any questions or anything before I call it quits for the day and we find somebody here to raid? I may or may not stream tomorrow. I don't typically stream Tuesdays, but I might. If not, I will be on 1 p.m. Eastern on Wednesday. And I might stream in the evenings. If I do that, I'll probably work on the bot. But I don't know. I'm starting to get pretty addicted to working on this thing already. Let's see. We're all Rust people here right now, so we should probably look to see who's on there first. Oh, I forgot this doesn't tell you what people are streaming about. They really need to change that. Because all of the lists don't tell you what people are streaming. You have to come in this way. Every time I go to the LiveCoders one, it's the same problem. Okay, what do we got? We got Python and Flask, mobile. There's us. Indie game dev. Who runs LiveCoders? C# Fritz is who started it, at least. What do we got? Live CEOing. Oh, we've got RW Grimm. If we're all Linux folks here, he's the maintainer of Pigeon. I don't think I've rated RW Grimm. Yeah, it's C# Fritz. C# Fritz. So, all right, let's raid RW. So thank you all so much for hanging out. Thanks for the follow, VR Son. Again, I'll be on Wednesday. I'm usually on Monday, Wednesday, Thursday from 1 to 4 Eastern Standard Time. And then sometimes I get on in the evenings and weekends based on, you know, what I'm working on or what's going on at home. But those are the times you're guaranteed to find me. Thanks again.